kill the stream and run it from a phone?
No. How about now? Let's see. Let me see. Is there any sound now? Is there any sound now? Are you hearing anything different?
I'm just
Are you hearing it?
So
Maybe? Baby? Bamboo Lab stuff? Have you tried turning it on off again? We're working on it.
Okay.
Yeah? Yeah, we got sound. Sound. Look at that. See? It's all coming up Millhouse right now. There we go. Sound is here. Fantastic. This is wonderful. Yeah, sound. We got audio, but it's faint. Sound, yes, sound audio is good. Got audio now. Don't touch anything. We hear you.
We're good.
Heck yeah. Heck yeah. We
We'll just jump right in with Chris.
are on brand. All right, welcome to Formnext 2025. I'm going to bring Christoph from Isago, and we are going to talk about some cool stuff. This guy, come here, come here.
Hello.
This guy, so Formnext is 10 years old. Christoph has been here for all of it. Wait, get over here.
Over here,
because they need to be able to see you, see?
There's the camera.
Yeah,
Sorry.
yeah. Formnext is 10 years old, but Christoph did something incredible. You came to the Rocky Mountain RepRap show.
I did.
This year, but earlier this year, and it was really cool because as Formnext, for the legacy has been industrial, professional, but you dove headfirst into some DIY and consumer, right?
Yes, indeed.
Well, first of all, how was that for you?
It was fantastic. And it was actually a few hours before the event even started that I came in touch with AM already. Because I took an Uber from the airport and came to Loveland. And my driver, we were chatting away. It was really, really nice, fantastic talk. And then he asked, what are you doing? And I said, oh, nice, the trade show about additive
Christoph's
manufacturing.
mic is muted.
Oh no.
Hold on, 1 second.
No, it's not.
It's working?
Yeah, it's totally on.
Are we good?
Yeah,
Okay.
yeah.
Anyway, so the driver says, fantastic, I know, I have a printer at home. So that was the first indication that obviously there's something going on and people know about additive manufacturing.
Okay, that's good.
And then as soon as we walked through the doors of the festival, that was really fantastic. It was an amazing atmosphere, a real buzz going on. You could see all these people chatting away in depth about AM.
Yeah.
And that was really quite special.
That's
I
cool.
must say.
What was your favorite thing you saw at Rocky Mountain? I just want to get that out because I know you saw a lot of really cool stuff, right?
Yeah.
But as someone who's been in the industry, at least at the industrial side, 10 years, putting on the largest show in the world, diving into that DIY segment, there must have been something that just kind of tickled your mind, right?
Well, there was loads going on. You could do your own sort of EDM with a little tabletop machine.
yeah.
You could pick a lock. Fantastic.
That's right. You could pick.
I managed to do it. And also I saw this fantastic wheelchair that grows with the user of
That's
the
right.
wheelchair.
That's right.
And that was a fantastic piece or fantastic project because it touches the lives of people. And that's something I really appreciate and really like because it's very haptic, you know what you're talking about, you can see how it helps people, and that was fantastic.
I'm really happy that you brought that up because that was made by Make Good.
Yes, indeed.
And they use Bamboo Lab printers.
Right.
And Bamboo Lab brought Make Good to Formnext, and they're over at the booth.
indeed.
Yeah, so it's really full circle.
again.
It's full
Here we go.
circle. So then in talking about Formnext, being the show that's globally recognized as the largest additive manufacturing show, there's been this change in 10 years. I mean, there's been obviously the focus can drift depending on what's new and what's cool, but I've never seen so many content creators at Formnext as I have this year. I know they started coming, but this is a really relevant show, not just for blogs and for the written word, but for video, for TikTok, for live streams, right?
And I think it's about getting the word out, motivate people, inspire people, and that's something you guys and also your colleagues do at the show. And that's fantastic to spread the word about additive manufacturing, because in Germany you don't take a taxi and the taxi driver says, I know additive manufacturing. So getting the word out is the key. And as you mentioned the shift in perspective, a shift of focus, and we can see that as well. In the early days, 10 years ago, I joined in 2015 the Formnext team, which was the initial year. And yes, there were desktop machines, and yes, we printed models in, for example, for architecture. There were some very basic projects, models that were being produced. And now, the capabilities that are available now, you can see the shift also on the show floor. And you can see a shift in the usage and the adoption of additive manufacturing and the consumer machines, consumer prosumer machines.
Yeah.
So it's, again, a shift in perception of these capabilities.
Well, and that those capabilities and shifting the perception, I like that you brought that up, because mentioning that the consumer brands are now being more a part of Formnext, it's just as we see consumer-facing brands offering prosumer or greater services. One example being Mosaic. They had the pallet device for consumers to be able to switch filaments, but now they offer the array and the element being in the array, and it's very much an industrial offering. I was curious about what you're thinking, and what are we going to see over the next couple of years at Formnext? Do you think more consumer-facing brands are going to find industrial footing, or do you think we will see more industrial-focused brands finding consumer footing?
Ooh, that's a good question. I'm not sure if I can answer that, to be honest. What I would like to point out is that the user, at the end of the day, sort of determines the way forward. And as we see more users using these machines for entry-level applications in their companies, and maybe even just at home, and then bringing that to their company because they have a job, a daytime job they have to fulfill, and maybe they have a challenge there, and they use that technology to solve that challenge. I think that's the entry point for AM in a broader scope.
Okay.
In the industrial realm. So, and to cater for that, obviously maybe both areas have to change. The consumer more towards the industrial side, and the industrial side more towards the consumer side.
More
maybe
of a blend. There's a more
exactly.
blending there.
Exactly.
Oh,
Perhaps.
Okay. Does the blending, here's something. Does the blending help influence education?
Education, again, is a different topic. We have loads of requests from teachers, from professors of, for example, there's a working group within the high school. They do additive manufacturing or 3D printing in a little workshop.
Wait. Did you just say? Okay, wait. Let's just hold on
no,
just a sec.
sorry,
Like,
yeah.
There's additive manufacturing. There's 3D printing. I mean, really, we're talking about the same thing, right?
It is the same, exactly. It's a bit of a question. I know. We always fall for that trap. It's the same thing. You're right. Well, the principle is that.
The principle is there, but I think in just lending itself to that education thing that I mentioned that you started to answer, I'm really sorry to interrupt, but really it brings up a good point. Do you think that if we reference more of what's here as 3D printing rather than additive manufacturing, do you think calling it at the industrial level additive manufacturing is, I don't want to use the word gatekeeping, but do you think it's keeping people from being interested?
I'm not sure. I think for us it's a synonym, but as you said, you saw that I stumbled a little bit.
Yeah. I mean, and you've been here a bit.
I know. But I would say because in high schools, obviously you don't necessarily have to have the full process that you need on an industrial scale. So there's certainly a difference in the process. I would say in the process chain. Whether you label it as 3D printing or additive manufacturing, at the end of the day, doesn't really make a difference. I'm not sure if it makes a difference in the perception. I honestly don't know.
Okay. One of the things, though, I think that I'd love to get your take on is having 10 years of experience behind you. For the 11th year of Formnext, we're talking next year. I mean, we already know this year is just a smashing success. The halls are busy, it's fun. But now knowing what you know and what you've learned and the experience that you've gained, what is something that you want to see perhaps at Formnext 2026 or 27? Mm-hmm. Is there a technology, a process, a material, an age group? Is there something that you would love to see be a part of that future Formnext exhibition?
Well, first of all, I would like to see more business cases, because that's already a shift that's taking place. In the early days, it was very much focused on the technology. Which machine is quicker, which has the more build space, etc., which is still relevant.
It's still very relevant,
no doubt about it. But at the same time, if you're talking about the adoption on a greater scale, you have to have relevance. So you have to have the right business cases. I was just talking about solving your challenges, your everyday challenges in a company. And there's plenty of companies in Germany that are a bit more traditional, perhaps, in Europe that are a bit more traditional, that you have to first sort of motivate to have a look into it. And that's what I would like to see, more smaller, medium-sized companies adopting AM. And to make that happen, I think we have to focus again on the business cases, on solving these challenges.
Oh, because you have these companies, these small to medium scale companies who are using legacy processes
For sure.
that many of which can be, with some fiddling, additive manufacturing cases.
Perhaps.
And so at Formnext, then you just want to see more of those people who are adopting additive manufacturing and solving problems via 3D printing that may not have been solved before.
Exactly.
Ah, okay. So is that what you see? Is that where you see the hockey stick of adoption, you think, solving those cases? Or do you think there's like a magic material that needs to be invented, or do you think a process needs to age to a certain part before? Like what's going to give us that hockey stick?
I think the broad adoption.
Yeah.
So I would say it's a scale sort of in adoption of different companies discovering AM for them, for their business cases, for their production. Maybe not for the end product, but maybe along the way, maybe in their production process. I think that's maybe the hockey stick.
Okay.
We're looking for.
Oh, I'd love to see. I want to see that. I mean, right? If any one of us could actually say what the hockey stick was going to be, we would have done it by now,
Yeah,
and we would have seen the hockey stick. I know that there has been talk of a contraction within the AM industry over the past couple of years. Do you think that's still the case, or do you think we're seeing a resurgence?
I'm not sure. I mean, we see Formnext is a little bit small this year, so we see that some companies are leaving the AM space, which because they focus on different topics on their core business, perhaps. So you can see that's where our format shrinks a little bit. It's not massive, and given the circumstances, it's still very acceptable. It's all good.
Okay, good.
And for the future, obviously, we would like to see that growth again, to come out of it. And we're talking about adoption, widespread adoption, and that's where growth will happen again.
Yeah, that's true. That's actually a really good point. I'm going to check and make sure. Hey, Peter, everybody can hear Christoph, right? We're good? Excellent. Okay. I just want to make sure, because he's saying some really good stuff here. What's been your favorite thing about Formnext each year? Is there a certain...
Each year.
Well, what I'm thinking is, like I told you about the process, or the tradition we have,
Yes.
where we go get that meal pre-Formnext,
That's
right?
That's
So is there something you and your team do before every Formnext? Like, do you hold a drink high and toast to the exhibition to come, or is there a certain note that you write yourself? Is there, like, is there this tradition that you found in the past 10 years that you've done, whether purposeful or not?
It's very unspectacular, to be honest. It's a dinner on the night before the show.
Okay.
Usually it's a dinner. Last night we had pizza in our office here, and we all had a drink. So yeah, obviously there is this toast at before Formnext. There's obviously our party each Thursday of Formnext, which is taking place in 2 days' time. A big event. I'm not sure if you have ever joined. I don't think so far, right? Have you joined?
I don't know. I don't know.
Well, this week you have to.
Okay. Tell me more about it.
It's a big party. It's like 2,500 people in one exhibition hall. Big band, big stage, music, food, drink.
That sounds great.
Yeah.
I'll ask David. Maybe we can go. You never know. Okay.
Or whenever if you're ready.
Oh, well, we can catch up a little bit. I think we've spoken a lot. I think a lot of people have gotten to get a glimpse at this. I've got one more question for you before we have to let you go. Formnext being a solid brand here every November in Frankfurt, Germany, how do you grow the Formnext brand itself to be either thought of more throughout the year or finding itself in more geographies?
Well, we do have a Chinese event in Shenzhen, so that's one full-scale Formnext, a little bit smaller, yes, but it's a proper exhibition. We do have a forum in Tokyo, and then we have different touch points. We attend different events, we sponsor different events, like when we flew out to the Rocky Mountain Rep Festival. So we try to get as many voices from the industry and bring them back home to learn from it.
Okay.
Shape our event.
Okay, good.
And then throughout the year, of course, we do some other stuff, like we have a magazine, with different
Yeah.
content formats, so there's lots going on.
Okay.
Yeah.
Will you be, real quick, will you be at any of the consumer shows next year?
Well, I hope so. I
hope
definitely hope so.
Yeah?
Yeah, for
All right.
So you coming back to Rocky Mountain?
Are you coming back to Rocky Mountain?
I'll do my best. I'm not sure, but I'll do my best.
It was cool seeing Christoph not in a suit.
But talking of which, I would just give a quick shout out
Absolutely.
to Stella and Christine, who can't make it this year. So hopefully you can make it next year, and all the best for you at home. Next year, I hope.
There we
See
go.
you here.
All right, Christoph, thanks for letting us back.
Thanks for having me.
I appreciate it. Man, okay, go have a good rest of the
You
show.
too. Enjoy the show.
Yeah.
All the very best.
And I'll tell David we got to go to that party.
Please do. Thursday night.
Sure.
He's in. Are you in?
Yes, yes, absolutely.
Talk and we'll go party.
Perfect.
Yeah,
We'll do that.
all right, good.
Enjoy the stream.
Yeah.
All the very best.
See you later, Christoph. Look at that. That was Christoph. Christoph of Masago of Formnext, a lovely human being, someone who gives warm hugs. Man, I know it was a little bit of a rocky start to the stream, but man, this was great. Let's see. I've got the stream up. I've got some comments in front of me. Oh, Hendrix here. Faux Hammer's here. Hey guys. Raven Dark Cloud. That reminds me of the time I met Joel at PDX Mini Maker Fair before he got big. Yeah.
I'm going to take this.
Oh, yeah, you take that.
And apparently people had the audio really loud when they couldn't hear it. And then when it got fixed, it scared the crap out of a whole bunch of people.
Really? I scared people from my loud audio?
You need to apologize to the audience.
Okay, I will, absolutely. Audience, it's me, Joel. I come to you with an apology. I know that the audio itself was kind of quiet, and then without myself knowing it, just talking in my normal tone, the audio got fixed, and apparently I scared a non-zero number of people. I'm really sorry. Oh, are we here? Okay, there we Hi everyone, it's Joel. That's fantastic, Peter. Thank you for that. Oh, we're getting our next guest mic'd up. I just want to make sure you know that there is a new video on the channel right now, and you should cue that up because it's a good one. Oh my gosh. Roger Essig Artist, I will never forgive you. Right, contact Bamboo Stream. Bamboo had problems with their stream too. It's just starting. What?
Prusa, too.
Prusa too? Look at us. We're
And our quiz show is having issues with people signing in because of Cloudflare.
And Cloudflare is causing issues with the quiz show sign up. That is sad. Oh man. JP Simon 5567. Yes, interested in Joel checking out the Cheaty Max 4. I am as well.
Joel, you ready?
Oh, is it time?
Just check your jacks in all the way.
It is in all the way. Are we good over there on audio? Okay. You promise? The guest's mic is blinking. Why is that?
What?
Oh no,
Just turn it on.
oh you did. Okay, good. Maybe that's what it. Oh, he's good. Mike, say something.
Hello.
There we go. Okay.
Surprise.
Here, trade me this. David, come here. I'm going to hand you that.
Thanks.
Next up, it's a fellow you've seen before. This is my friend Mike from E3D.
Hi.
Hey, dude, come here.
Good.
Come on.
Having a cuddle?
Have a little cuddle there. Hey, come around here.
Come around here.
Come here. People want to see you. There's a camera right there.
This camera.
Yeah. Oh my goodness, you brought props.
Brought
So,
toys.
E3D has something super brand new.
Yes.
And you were what part of it? Did you design it?
Yes.
This is your baby?
This is my baby.
Oh, this is exciting.
It's very
Okay,
exciting, yes.
Peter, let me know when you can see this.
So we'll go for these guys first.
What, these guys first?
These guys first.
Okay, take me through it.
This is my babies. So, here at Formnext, we are debuting Obsidian 500. So, Obsidian 500 is an evolving Obsidian, which people already know about.
Right.
It wasn't perfect. There are a few things that we wanted to improve, and we feel like we've smashed it, and we've done that.
Really?
So, yeah.
That's great. So 500 degrees Celsius, right? This
Yeah.
is, we are melting in nearly any
Everything.
everything. There's no polymer that melts
No.
hotter, right?
So the reason for the 500 is to try and reassure people that this one, everything. So obviously some printers themselves don't go to 500C on the hot
No,
end.
no,
but,
no.
But our hot end is not going to be your bottleneck
Oh,
in that case.
so if I wanted to some glass fiber peak,
Yeah.
I could do it with the Obsidian 500
Correct.
easily.
Yes.
No problem.
No problem.
Have you done it?
Yes.
Yes.
So we, essentially the way this came about is when we launched Obsidian, most printers were kind of hitting that 300C temp limit.
Yeah,
So
yeah.
that was most hot ends. And in the last few years, that's kind of pushed 320, 350. We're seeing it creep. We're getting people printing.
A lot of 350s, yeah.
PPS now is becoming much more common, which is a
Yep.
crazy cool material. So we wanted to evolve Obsidian and make it compatible because we had our HTA coating range, which is something that was fine for high temperatures, but it wasn't as wear resistant as an Obsidian was.
Oh.
And it wasn't, it doesn't have the same non-stick technology that we have for Obsidian.
Okay.
So what we've been able to do is we've essentially combined the high temp of our HTA range and the non-stick and even more hardness than the Obsidian range, smashed them together and made some super cool products.
This is okay. So you essentially just went uber material wizard, figured out some chemical things, and all of a sudden,
Yeah, Uber Material Wizard, and then we're done.
that's so cool.
So we have
well, hold on. In the testing of this,
yes.
what is the coolest material you think you've printed with?
My favorite test that we did was we have some materials that we like to do really high throughputs through that we know are common, and we use them for benchmarking and validating stuff. And then we also just wanted to be really sure that we were going to catch everything else. So we devised a test that internally we just called the gauntlet. And one nozzle was going to run the gauntlet.
Okay.
And we got a spool of basically everything we could find. And the same nozzle just chewed through one spool of absolutely everything else. And it still was brand new at the end.
Really?
Yeah.
That's
So-
huge.
So it was doing carbon fiber peak, and then it was doing some stuff like tungsten fills. It was doing the normal like carbon fill stuff, glass fill stuff, aramid fill, like basically anything. We made sure that we put everything through these nozzles.
That's really cool.
validate
Okay.
it.
Well, that's good. That's what everybody wants to know, though, right? They want to know, like, have you thrown it through it? It's like, yes.
Yeah,
They
well,
can ask you anything, and you're like, yeah, of course.
One of the things is like, when's the nozzle going to be ready? We want to sell it now. It's like, well, we just need to wait because we've got to put some material through it, right? It takes a little bit of time.
But now you're confident. You put the material through it. It looked brand new when you were done. Like, is it for sale now?
Yeah, so Obsidian 500 went live this morning.
Yeah?
So resellers and E3D's own web store.
Oh, no, everybody.
Everybody. And we have sort of committed to multiple form factors all at the same time as well. So shout out to our operations team for getting them all ready. But we've got Bamboo Lab X1C, P1S, then we've got the brand new, this is the H2D, H2S, P2S.
Okay.
You can stick it on the left-hand side of the H2C.
Oh,
as
yeah,
well.
right there, over on that side. Yeah, exactly.
So that's brand new for us. We've also got on the Prusa side, we've got standard flow and high flow extruder nozzles. Then we've got Revo nozzles, standard flow and high flow, all live all at the same time.
But, okay, this is an interesting problem, though, because you've just developed a nozzle that can hit any temperature that any machine at this point can really throw at it, unless you're printing glass, which you're not. So any machine. And so you have a 500C plus rated nozzle on a 290 heat block on like a Core 1, or like on a 350 heat block on a H2D. So is it for upgradability, or you just want to give like peace of mind?
So it's both. So if another variant of a machine comes out, then it's going to be compatible with that.
They can.
Yeah, and then say you want to mod your own machine, so you change. Like Prusa's announced their high temp Core 1.
Yeah,
right?
I saw that.
Obsidian 500 is going to be the default hot end for that.
Oh, really?
Yeah.
Oh, good job.
Cool. Yeah, posh. Yeah, and then we're also making it so as other machines come out, or if people want to change stuff, it's fine. And if you don't need the 500C, you're still getting 5 times the wear resistance of an Obsidian at least, because it's film dependent, and you still get all the non-stick stuff. Because blob monsters kill prints and it sucks. So
They do. Yeah.
Costs.
Wow. How cool. Like, how happy are you that this is like out? Going through the test gauntlet, you must have just been smiles as you're seeing it succeed over and over again.
It's good times, and obviously we did Obsidian, we teased that, and then there was a small window where people were interested in that, and then before that came to market, there was a small window. And so it's really, really cool that we've been able to, it's been a bit more seamless this time around. Here it is, boom, announced, and it's in stock and available for everyone to buy on the same day.
Just like that. Oh man, what do you think people are gonna say? Because I'm trying to think, right now, other than that Prusa announcement, 350 is the highest that most consumer level machines are at, right?
Yeah.
I know there was some announced. There was that one that had like a. I don't even remember, but it was like supposedly it could print peak, but it wasn't good at it, or.
Well, so you kind of have phases of temperature. When you're like in the 320, 350s, then all the high temp nylons, PPS is included in that, and then after 350, you're like, I want to print peak now.
Yeah.
That's what you're saying. And the peaks all have different, like some of them are 380, they push into the 420, 430. Doesn't matter which one you want, these nozzles are good for it.
So with the nozzles then, do you have a heater block that'll do 500?
Again, we're now talking different ecosystems. If you're in Revo, yes, because we sell Revo High Temp. It comes with, we sell that in two different versions. One that's slightly lower cost and is good to 400C. And if you need the 500C, we have basically it's a higher spec, higher wattage heater, things like that. But yes, we sell both of those. So if you're in a Revo ecosystem, all the way to 500, heart's content, let's go.
Yeah, well, I mean, that's what I mean. You guys have that Revo system, and so it's cool. Just thinking, someone who's building a Voron, for example, can now build a Voron that's easily capable of printing like these advanced polymers, these engineering polymers.
Yeah, we actually snuck a few samples to some of the Voron guys.
I would imagine you did,
Let them have a play with those, and feedback's been really cool, so that's great too.
Yeah, what has the feedback been like? People really enjoy printing with this thing?
Yeah, it's good. I think the big thing for people who've not used anything before that with our non-stick stuff in is that it's like a real quality of life improvement. Because number one, you're just not getting the blobs building up during the print, and then number two, if it's between prints, you just get it hot, one wipe, and you're just done. And you can also hit it with like a brass brush if you want to. If you've got like an if you've got like an automatic brush cycle on your Voron, for example, to clean before the print, that's not going to destroy the nozzle. It's good for that.
That's cool.
We actually had some funny customer support tickets a while ago where people were like, "Hey, I think the coating's coming off my nozzle," and it's like, "No, actually, what you're seeing there is the nozzle's destroying your brass brush." You just need to wipe the brass off.
Are you serious?
Yeah.
That's what it was?
Yeah.
Wait a minute. Wait.
On the like little bristles of it because of the way they're coated. Yeah. When you like ram a nozzle.
Well, it's not melting the brass.
No. It's just like particulate comes off. People thought it was damage to the nozzle.
Really?
But it was damage to the brush.
Oh my gosh. I bet you didn't think you'd be seeing that support ticket come.
No, no, but there we go. At least it wasn't the nozzle, right?
What's the coolest thing you're looking forward to printing with one of these then? Now that it's out and you can talk about it, is there something you've been dying to do but you haven't been able to?
I think on the original Obsidian project, it was always that we couldn't go into the peaks. And so it's always fun to do a little bit of peak, but probably going to give PPS the mega shout out because it's such a cool material.
It is good. Yeah, I really like it.
The metal effect when you knock it on stuff.
Yeah.
But also, like, if you read about it, it's like doesn't dissolve in anything below 200C. It's like completely chemically stable. It's just a mega material.
We have some cool rally car projects that are going to be using some PPSCF for parts, and it's like.
It's cool.
That's cool. Like, it's just good stuff. Okay, so we've covered this. This is good. Do you get to talk about that one?
Yeah.
Okay, let's bring it out because I'm gonna put it right here.
So, this is Fuge.
Fuge.
Yes.
Like luge, but fuge. Fuge. How'd you come up with the name?
Yes.
Okay. Perfect. Yeah, that's great. That's great. It is an interesting design. What is Fuge?
So Fuge is our next generation high flow system, high flow technology. So we are teasing it, showing it off for the first time at Formnext today. So Fuge is another take or another way that perhaps we could approach increasing the flow of materials going through a nozzle. So typically the thing that is going to slow you down in melting plastic is getting the heat to the center of the plastic. So if you imagine you have a circle cross-section area, getting the heat right to the middle.
Yes.
So heat transfer through the polymer is much worse than the heat transfer through like the heater block and the nozzle
Right,
itself.
and so that's where the CHD came about, of splitting the polymer path.
So you split it into
for more surface area.
You then get more surface area or like in perimeter that you can get.
Well,
the heat through.
less polymer, less distance of polymer to travel through to get the heat in, right?
So this is a different approach where you're going from a round filament, you then squish it down.
Yeah, this looks like the end of a toothpaste tube, right?
Yeah, and then opens itself back out again. And what that does when we compress it is it gives us more surface area to get heat into the plastic and reduces the distance the heat has to get through to get to the coldest part. and we're able to see some massive flow rate boosts. We've got a cool printer. It's just like a tech demo on our stand.
I saw it. It's really cool.
It's like a modified rat rig V-Minion rocking some enormous servo motors.
And it's moving.
It's moving.
It's like chooching along.
Yeah.
So is there, because there's a pressure that builds up with the material behind the nozzle as you're printing,
Like a back pressure.
Like a back pressure, yeah. Is it different here?
So we're still, obviously it's not the same as if it was a cylinder. It's not the same as if it was like one of our E3D high flow products in the current generation stuff.
Right.
Because you've got the 4 holes. But it's not inflating the force requirement so much that you then can't print it, for example.
Right, well, I mean, obviously, because I've seen it working, and it's absolutely brilliant.
Yeah.
But is there what's the configuration? Or what's the...
Like, how are we doing it?
Yeah, how are you doing it?
So it's been really cool. We've been working on it for a while, actually. Funny story, the very first one of these that ever got made was Sanjay crushing a tube in like a vice. So if you look at this, imagine you were a cylinder first, right?
Yeah, well, of course.
Then you squash it. That's like the very first iterations of like the concept of the design. We've been working on it for that long.
Wow.
Yeah, it's a really cool thing to finally be able to show.
So there's still echoes of Sanjay's design coming through in E3D's products.
Of course, yeah.
Oh, I love hearing that, man. I miss that dude.
So lots of refinement, lots of changes, lots of understanding what we need to control, how we need to control it to make it like a production viable thing.
Well, this isn't the size. Like, this is blown up a bit, right?
Yes, this is a huge one.
Yeah, yeah.
Well, not as huge as the one on our stand.
That's big.
That's big,
But
yeah.
we're talking about something that's supposed to fit within kind of this sort of surface area, right?
Correct, yeah.
Here, Peter, can you see that? Like, imagine that, but this size. Yeah, that's... Okay, what's the timeline on something like that?
So at the moment, we're just going to say next year.
Okay.
We're going to launch some products with it next year.
So what would you call the printer at the booth at Formnext? Is that a tech demo?
Yeah.
Okay.
So it's a kind of a custom designed hot end that's on there that has this inside of it. It's obviously what we want to do is we want to showcase it to people, and then we want to work with all of our OEM partners to try and bring it to kind of their ecosystems and push it that way.
So then is this and this going to be together?
Maybe.
Like a 500C Fuge?
You could say.
Because really, if you start moving that way, then we start talking about a higher maximum volumetric rate for engineering polymers,
Yep.
which means, and if you can print those faster and get the same mechanical properties, but faster parts, like, you're changing industry.
Yeah. So E3D's original core motto that we still go through whenever we talk about what we're doing as a business, and the vision is to change the way humanity manufactures goods. That's the tagline. I'm sure Josh and Dave will be very pleased that I've managed to get that into this live stream. But yeah, I mean, that's what we want to do, right? We want to move things forward.
Of course.
Play our part.
This is just like when the V6 came out, man, I don't know what's going to top that. It's going to be really difficult. The Revo system comes out. Man, that's really, really cool. I don't know how they're going to top that sort of thing. Oh, like Bamboo micro. Oh, wow, Bamboo really did something cool with that hot end. I can't believe that. I don't know how anybody. Now you're like 500C. Now you're like
it's fun,
dude.
Right? It's fun, right? Yeah. I mean, that's what we want. We want.
Well, yeah, I know, but I mean, it's crazy to me how long that's been in development. And it really makes me think about all of the other things that you can't talk about that you guys are working on that are still even next generation.
Yeah, and if only we could talk about it. Hey, one day, maybe we're doing this again, but yeah, there's some exciting stuff still to come for sure.
What is the next 12 months for Fuge looks like?
So
is there certain testing that you want to get done?
Yeah. So at the moment I think it would be fair to say we've done a lot of prototype stuff. We're moving towards more of a productionizing the products. Exact timelines on when they all become available and which ones come first and all that, not really sure, can't say. So it's the productionizing. So
Hiring more interns to squish the tubes.
yeah, they just sit with like little pair of nipex. And
Oh,
that's
is that it?
Just-
Just yeah.
Maybe.
Calibrated nippers, you know.
Maybe, yeah. We played with some cool ways of making them. At the moment, we're actually making them as like in two halves on like a sliding head lathe, because then we get maximum capability to prototype with all different geometries and try different tolerancing and all that kind of stuff.
Oh, okay, that makes a lot of sense. I get that.
Yeah,
Okay,
it's good fun.
but I was like I don't like the CHD nozzles. Those are a manufactured piece. There's some.
Madness and
Yeah,
witchcraft
I
in
mean,
there,
I would
yeah.
imagine like that's not how things like.
Yeah, the drill doesn't do this.
No, it doesn't.
Yeah.
And so manufacturing that like two halves, but like going to mass manufacturing, is it gonna?
It's not the only way of manufacturing it that we're exploring.
Okay,
But that's how we've been doing our R&D. Let's put it
okay,
that way.
and that's good enough for R&D.
Yeah.
Absolutely good enough.
Yeah.
Oh man, Mike, this is cool, man.
It is cool, isn't
Like
it?
this is cool. Like you just spend all your days thinking of cool stuff, don't you?
That's the plan, yeah.
What's your favorite part of doing this?
Doing this.
No, not.
No,
Obviously,
this-
it's me.
obviously,
but no, you're just. You've been at E3D a while.
Yeah,
like
I
you've
think-
been doing really cool stuff. And it's
Yeah.
only when something matures to a certain point that you get to talk about it. So,
I think it's pretty cool
what's the coolest part, man?
when we play with something and we say, is this going to work? And then we can make one work. Then we have to make 10 work. And then we have to make thousands work. And I mean, it is pretty cool how like, we've just talked about some tech that you can put on a machine that's not that expensive. And we're going to be printing PPS and peak, and it's not.
I know. That is.
We're not buying
blows my
million-pound
mind.
machines to fit this tech to
No.
anymore. We're fitting them onto much more affordable things, which is awesome.
Do you see a future where cheaper machines are able to build qualified parts?
I think, well, the price point is still coming down for the
Yeah.
ones that would definitely do that.
Well, of
so
course.
yeah, I think they'll get cheaper.
Well, like as an example, I know Mosaic has their Element.
Yeah.
Vision Miner has their 22 IDEX V4 now.
Yeah.
Both machines capable of printing engineering grade materials like at high quality levels. Like, do
How
you
low
think
can the
it?
price
Yeah,
point
do you
go?
think it goes lower?
think
Like,
it goes
are we
lower.
sub 10? Are we sub 5?
I think we're sub 4.
Are we sub 2?
There'll be a delay though.
Are we not already sub 2?
No. What I'm saying is sub 2 for qualified part. Like,
Yeah. Peak only.
yeah, like is Boeing gonna go buy a sub $2,000 machine? You think to print parts for airplanes?
Or 1,000 of them.
Yeah, right. Because at that point we start talking about this,
Yeah.
the scale that you can do these crazy things at.
Which is what they want to be doing, right?
Well, of course,
Yeah.
giant print farms of 500-degree machines.
That each cost $500 and they're printing qualified parts that can fly in aerospace. That'd be pretty cool, right?
Yeah. God, this is just—it's so cool to think about because it really lends itself to a really fun future. Something where kids are going to get to like make parts out of peak,
Yeah.
like engineering classes. It's
I
going to
mean,
be
at
fun.
the moment, my kids are happy with the Benchy, but if the Benchy can be made of peak, then that's pretty cool, right?
Yeah, I remember an Ultim Benchy, I think it was. Like, it could withstand fire pretty well. How old are your kids?
6 and 7. We don't give them fire yet.
6, 7?
Yeah.
Do they ever do that?
They do. I don't get it.
Yeah, I don't get it. It's all right. It's good to know you don't get it on the other side of the
Yeah.
pond, too. What's that?
Check it out. You guys want any water? You want any water, man?
You want to water?
Yeah.
Sure. Ooh. There we go. I'm going to grab a water, too.
Fancy.
It's tough talking for so many days of shows.
We're doing 3 hours on the bounce.
Cheers to you, man. That's right. Not sponsored.
Not sponsored.
Yeah. What's your favorite part of coming to Germany for the show?
Formnext is massive.
I know.
Formnext is massive
It's
on
huge.
on a scale that is like one of one, right? Formnext is.
It's one of one, yeah.
the-
That's a
it's
good
the-
way to talk about
It's the biggest. You can see so much cool stuff. There's like giant robot arms with welders on the end of it, and then we've got $100 £100 machines printing kids' toys in like the same hall.
There is this
Everyone's
weird,
here.
what is it, dichotomy between engineering grade materials and like $100 hobbyist machines, and they just kind of coexist.
Yeah,
I don't get it.
and everyone wants to look at both.
Yeah, it's cool to see. Like you're up in 12.1.
Yeah.
Man, and it was buzzing. There's cool booths all around you guys, and just being able to, oh look, this is printed in metal, and then you go to E3D, and all of a sudden they get to see the Fuge, and then they go to the next booth and whatever, and
everything's there.
It's everything.
And it's a big. I like this show because it's also like community style, like in the sense that it's not a rep festival. But we go around and we see people that we've seen before, we've seen them again, and everyone comes back and everyone's brought new cool stuff to show off. You come back to the party next year and they've been doing this.
And there's new cool stuff, yeah.
And everyone brings cool stuff.
I mean, there's rep shows are great.
I love rep fests.
Do you think, let's see, what would be the next one? The next one would be, Sanjay Mortimer rep show, right? You will obviously have that at the show.
We'll be showing it, for sure.
Yeah. I'm not saying for sale, but people that can't make it to Formnext can come see it in person, right?
Come see it in person. Yeah. I'm sure we'll have the printer there again.
Oh, you better. You probably have a new version of it. Like by that time, this is months away.
Maybe it goes faster.
Like the amount of iterations you're going to have is going to be fantastic.
I hope so.
One more question for you, Mike. Let me just take a sip of this. It's tough talking all these days, you know? Wow. What does next year's Formnext look like for E3D and what you're working on? You don't have to give away secrets, but is there something cool in the works that you haven't talked about that you think people are going to be really excited about?
There's some tech that we're working on that I really hope we can bring to Formnext next year.
Really?
Yeah.
Okay. Can you tell me a category?
Yeah, FDM. Sorry.
That's all right. That's perfect, though. That's a great way to end it. Mike, thank you so very much.
Thank you for having me.
Any spares here, feel free to just, send them to my house.
We got that.
Yeah. I got you going.
Not this one.
No, probably not that one. You should probably...
Probably take this as well.
That's right.
Thanks, Joel.
Oh, man. Have a good rest of the show.
Thank you.
All right. Hey, Peter.
We're going to try boost the audio a bit.
Okay.
But let the audience know so that they don't get...
Are we going to do it right now?
Yeah.
Okay. So for everybody watching, thank you very much. For everybody watching right now, we're going to try boosting the audio just a smidge. Just right now. Oh.
Hey.
Wait, there, you're me, right? There we go.
Oh, Jesus, you cannot see a thing. Oh, thank you.
You hold that while we do a quick
Okay,
audio check.
Audio check. Okay. We are going to check the... Oh, I look weird without glasses. I look like you.
You look hot and trendy,
You have
actually.
to hold this because I'm taking away the table.
Oh.
Whoa. Whoa.
Hold your mic.
I've got it. Oh, he's got muscles, isn't he? He's got muscles.
He's got muscles on his muscles.
Whoa. Oh, my God. That was, this has been entertaining.
This
so
is
far,
mad.
hasn't
Look at that. You jump on the bike and all of a sudden, like, bottles fall
I
over.
do apologise.
Jeez.
How are you?
I'm all right,
How's
man.
the voice going?
It's a little rough.
Yeah?
Plain air is dry, man.
Did you try the audio thing?
Just be super careful about stepping back here. I don't want you having the calamities. We both fall off together.
That'd be terrible. Let's look at comments.
What's people saying?
Hello's from Spain.
Wow.
He clowned Joel so hard. E3D Tool Changer V2.
All right, watch your back.
Bamboo release was lame.
They're bringing it in,
Magic
friends.
happened.
They're bringing
What?
it in.
Oh my God. Okay.
So listen, we're going to see you on the 16th of December, right?
Yeah, 16th of December at the studio.
Yep.
We are doing the live stream for Seattle Children's Hospital, giving away a bunch of stuff and raising as much money as we can. December 16th. Hey, you're going to be there.
I am going to be there. What
Sam
am I
is
going
gonna
to
be
be
there.
doing?
Oh,
That's the funny thing.
ooh.
What am I going to be doing?
It's going to be, I don't
This
know.
is this is like the EMP's being launched in, and everyone's looking to lose their power in the next few minutes. This is
That's right.
This is
Next item up for bid.
Here we go. Just,
All right.
Just pop. Oh, there we go.
Down in the middle.
Cool.
That's fun.
Doing
isn't
it live.
Joel, the table is a little...
I am not going to touch it.
Don't
You
lean
can
on it.
totally touch it,
Oh, hold on to it.
but hold on.
Yeah, okay.
We're just readjusting cameras, everyone.
Readjust cameras and audio, and 16th will be good. That's
I can't wait.
That's
actually.
about a month away.
It is.
So you have time to work on something.
I might be working on something right now. It might even be finished, actually.
Oh,
That's
really?
the- yeah,
Oh, really?
we're ahead of the
You
game
are
here.
pretty quick on these sort of
we
things.
don't mess around. Yeah, we've got some cool stuff coming up, and of course I'm going to be there with Polymaker and maybe one or two other companies. We'll see what happens.
Okay.
You know, see
Yeah.
who flies me out.
Oh yeah,
By the
you never
seat of
know.
my pants.
I do have I have an industrial smoke machine now at my disposal. That
Can
we
we-
will
can we-
know. Well, we're going to activate it when we hit certain dollar amounts.
Right.
Yeah.
Can we have people coming through the curtain to that with, you know, maybe they sing a song, a bit of karaoke.
Oh, yeah.
I don't know. Maybe.
Maybe not. Maybe not.
Oh,
Maybe
geez.
not.
Okay. Are they ready? Do you want me to? Okay, it's time for me to go. Dude, really good to see you.
Oh, good to see you.
Let's have an awkward hug.
Oh, good to see you, brother.
I'll see you next time. All right?
Yeah, next time,
Keep
Samo.
well. Keep well.
I'm just doing good here. Got an iPad. Sound is fine. YouTube is reload. The thing is almost as big as my ego. Intro music for each guest. Oh, we should do that. Yeah. What? I can't hear you. Oh, how is the audio, everybody? 3D printing nerd, are you going to have Neil Patrick Harris on again? I am going to try. Imagination to form. I am an industrial smoke machine. This is amazing. Wow, sound is fine. Good. Oh, bearded printer, what's up, baby? Armor 3D printing, what's up? Water is good. Peter. Thank you, sir. Could go up a bit. Sound, audio seems much better. Hey, that's great. Is Joseph coming on? Maybe. Maybe. Great volume. I got some thumbs up.
I love that you're behind this.
Oh, I'm going to hand you that.
Are we good?
I think so.
Ready for our next guest?
Yes. Oh my God.
Also going to
Oh my God. How you doing? It's been a year.
exactly 1 year.
All right. So, okay, the video that we did was amazing. Being able to showcase that massive part and being able to stand in that machine, that was fun. The process and talking about the car and stuff, and I was like, that was cool. And you did that bridge. That was cool.
Yep.
And so producer David said, hey, they're going to be on the live stream again, and they're bringing a massive thing. And I was like, yeah, that's a big thing.
Yeah, I mean, for our size, this is actually the smallest part at the booth that we could carry. So for us, it's not massive. This is a little bit as small as we go. And we
Oh,
go
hey, does
much
he need
bigger.
to step over here, Peter? Is he a little bit out of frame? Oh, he's good. All right, good. I just wanted to make sure. Because, okay, this is small for what you guys do.
Yeah, especially in weight. So this is around 52 kilograms.
Okay.
This is something we print roughly in a day.
Okay.
Our small systems go till 750 kilograms, and our larger go till 20,000 kilograms. So this is a drop in the water compared to what we print usually.
20,000 kilograms
Yeah.
of 3D printed material.
Pure 3D printed metal.
Which metals?
Any weldable alloy you can put on our machine.
That's a lot,
because
right?
We're just using a standard welding process. So think about aluminums, carbon steel, stainless steel,
Yeah.
duplex, nautical alloys like the bronzes. If it's weldable, it's a very high
Bronzes?
chance. Yeah, aluminum bronze. So maritime industry. Think
Right.
about printing propellers for boats or huge impellers for power plants. That's all in our product range for.
Oh, I didn't even think about that.
Yeah.
And so it's the welding process. Like this isn't this is direct from the machine. This is not finished
Yeah.
or post-processed.
Yeah.
Right?
That's a very good comment. So what you're looking at is pure weldments, and typically the high precision surfaces, they would need to be post-processed, either
Okay.
with traditional manufacturing like CNC milling, or if it's maybe less intrusive, some drilling or some turning.
Oh,
But
okay.
then you get like a pure part underneath that welding skin.
Well, being able to, so rather than, the other method would be milling this out of a solid block, right?
Yeah. Well, for there are many manufacturing methods. Maybe for this it would rather be sheet metal that you would weld, but still, coming back from a big block to a shape is a lot of material waste. While
Sheet
with,
metal? Like
Yeah.
this?
Well, yeah, some type of, let's say, pressure vessels or huge cylindrical vessels could
Oh.
be made from large sheets, which are bent and then welded
Oh,
together.
I see, I
So
see.
it's quite minimal still, but this is fully automated. We can do internal structures. You see these reinforcement ribs. That's all not really possible with traditional manufacturing.
Well, I was just going to say, you make a traditional, you could bend the aluminum into
Yeah.
a shape, but then this thing on the outside, how are you going to do, like, and it's all made at the same time, and it's all weldment, like, there's so many advantages to the process in which you're doing it.
Yeah.
Like, why aren't more people doing that?
Well, we're not the only one in the field. There's some other companies also pushing this technology really hard. It's a good question because welding has been around for 100 years, and this is basically welding but in 3D. Maybe it's the state of the technology. Now we are able to drive these robotics to do very advanced movements, very controlled welding, and that was maybe a little bit more difficult back in the day.
Do you have more than one robot going on a print, or is it just one
So
robot?
this part is small enough to be handled by one robot, but we do have multi-robot setups where multiple robots each have their own build space, and then the whole part can turn around or the robots can move around. So it's really like a big micro factory.
Oh, so okay, if I'm imagining things correctly, you've got a robot with a build space, a robot with a build space, robot with a build space. So then, that's always one of the questions I've had is how do you make multiple robots make one part? Because if a robot can only go this far, and this robot can only go this far, do you make the parts so they can crisscross over a bit?
That would be one method. The working envelopes do not necessarily need to meet. They do not necessarily need to overlap. It could also be that the part is on a positioner so that the part itself can move. So then you can just print little sections and those sections move around and you keep printing where it's empty, keep spinning, and then you can build something big. But they could also completely overlap and still work on their own segment as well.
Okay.
It's all possible. Or the robots themselves could be in moving platforms so that their build envelope is actually flexible. So either the part moves
an
or
arm
the
on
robot
on a rail.
Yeah.
That's a thing.
Yeah, that's a thing, yeah.
Jeez. Hello. What's your favorite part you've printed in metal? Because you've done a lot.
Yeah, so last year in the feature we did, we talked about a BMW part that they produced with this technology. I think that's very exciting. It's very accessible because they're really going to use this technology to print parts for cars, which everybody knows. But then we have been working on some parts for, let's say, the nuclear industry, which I can't go too much in detail. But these parts
you can't, huh?
these have very high requirements, so that makes it extra exciting to fulfill that with the right part at the right quality.
That makes a lot of sense.
It's great to be able to fulfill that need.
I was just thinking, I know with the car parts, you thought they were cool last year, but it's been 12 months. I wasn't sure if something came up. Obviously, you can't talk about the nuclear stuff, but did something come up that you maybe wanted to? But okay.
Yeah, well, at the booth last time we had the big pulper screw. Now
Yep.
we're showing a very big impeller. You could imagine that maybe this was used in the nuclear industry or oil and gas or whatever. But these are just massive parts. Which
How big
are
is
just,
it?
I think the radius is around 1 meter. It's 300 kilograms, so that's one I couldn't bring here. It's
That's
a little
fair.
bit too heavy.
Yeah.
I think the Formnext people would not appreciate that moving through the corridors.
Are you upstairs?
We are in Hall 12 downstairs.
Oh, okay. So for people that don't know, Formnext is 4 different massive halls. And there's 11.0 and 11.1, and then next door is 12.0 and 12.1. So to get this from 12.0 to 11.0, it's a distance.
Yeah.
It's far.
A lot of people were looking and asking us to stop and take pictures, so we made it just in time.
Well, you're famous now moving this thing, right?
Well, one part I didn't talk about that is actually maybe my favorite this year is a repair job we did. We have brought a large tooth of a mining bucket and that features a lot of wear and tear on the tooth itself. But it's also,
like a lot, yeah.
It's also prone to potentially breaking. It's a harsh environment. So on one side we have reprinted a part. So we've put it in our machine, scanned it automatically, and reprint the part that is missing. So we added metal to an already existing part. And then on the tooth side, we cladded it with a hard alloy. So it has an increased wear resistance. So it has an increased lifespan, and also not only does it have an increased lifespan, when it's broken, we can repair it and it can go back out there in the field. So it's quite a sustainable business case.
But being able to repair in place, you didn't make a part that got bolted on. You printed onto the piece.
Yeah.
Right?
So imagine a metal part breaks, you would have the brake line, and depending on how that brake line looks, we can either print directly on top of that, or we flatten it out a little bit, and then we can just reprint the part that's missing. So that's pretty amazing if you think about the resources used.
That's insane.
Yeah.
That's really cool. So then why aren't more people doing that?
Well, we are developing this technology ourselves, so I would like to think it's fairly new, and we're trying to bring it to the industry, show the industry that this is possible, and that this now, snowball effect, maybe that more and more industries can adopt 3D metal printing to repair parts as well.
People must think this is cool. Like when you go up to people and I 3D print things. I show them to people.
Yeah.
They like them. You can do way more than that.
Yeah, people are quite impressed. Sometimes they also don't know what they're looking at, especially if we show the milled parts. They don't realize it's 3D printed before and then post-processed afterwards. So that's why in our booth we have these raw parts, some partially milled parts and fully milled parts.
Oh, okay.
Because we've actually learned from experience that when we show the final part, people actually don't believe it was done with 3D printing. They think, oh, you just milled it from a block or something like that. So that's why we like to show all the phases. But yeah, the parts are pretty impressive.
Well, if you were to finish this, then this would just be smooth.
It would be smooth, it would not have any defects, but also we would only machine the useful surfaces, the mating surfaces with other areas in the machine. So we wouldn't necessarily mill everywhere because that's also not always necessary, and milling is also expensive. So we want to be a little bit economical with where we will and where we don't mill.
That makes a lot of sense. Okay, so you've got marine, you've got being able to machine print parts onto industrial machines. Do you think that this type of metal 3D printing is going to be available to more? Like, you have robotic arms that do it. Do you think it's going to come to a level of affordability that people could have it in their business and wouldn't have to call you?
So we're definitely aiming for a machine that can be anywhere without expertise knowledge, so that it becomes easy to use and easy to operate and control the process. We would like to see that this is a machine that is in metal fabrication workshops, but these are of course workshops that have the funds to buy a milling machine. So we're really still on that price level. Because we're using robotics, because we're using welders, that's something we can't really make a lot simpler. We could use maybe smaller robots, but the power source is also very important.
Oh, that's a good point.
And the price point there is quite fixed. If we would go in a lower price category, we would have to see if we can compensate with that with our own software for what we don't have from the hardware.
Is there, I know that robotic arms themselves are getting lower cost.
Yeah.
Could someone just attach a welding head to it and do what you're doing?
That's a good question, and if you look at the origin of MX3D 2014, you would see exactly that, an old welding robot with an old welding machine, not glued together, but bolted together, and that's how MX3D started, printing very small segments, showcasing that these two rough, let's say, known machines, the robot and the welder, can combine to a metal printer. A little bit later, actually, when we had the funds to buy proper new robots and good power sources, we actually started to fabricate replacement parts, and one of these was a replacement part for a welding robot.
Oh, really?
So we sort of did the full story where the robots are printing robots, so we can expand our fleet.
That's very RepRap. You've heard of RepRap?
Yeah, exactly. Yeah. So it's a very cool concept, but you know, these robotic parts aren't really in the realm of our business cases. So it was to illustrate a concept,
Yeah,
but it
of
didn't
course.
turn into a full business for us.
So for you in the business, a lot of it is going to be the software that's driving this, right?
Correct.
So then, for something like this, if we approach it using a robotic arm to print it rather than a layered process, how would your software go about making a piece like this? Would it create like a base shape and then add these, or is it built upon layer by layer?
Yeah, it's a good question. So the biggest difference between the industrial robots and the gantry type machines is that the robot has typically 6 axes of freedom. So there's 6 individual motors.
Right.
Which means that for every coordinate in 3D space, there's multiple robot configurations that you can have of these motors to get to that point. While a gantry machine has 2 axes, X and Y, and Z1. And that's like one position only. There's not really like a turning, or maybe
Right.
there are some more advanced. So with robotic tool pathing, the slicing is a lot more complex because we have all these kinematic possibilities, basically infinite. Then we look at the tool path, and then we have to come from those infinite possibilities of positions to get there to a strict constrained path for the robot and make sure that all those robot positions are in smooth order so that the motors don't have to reorient so much. So the
Oh.
tool path thing is very different versus gantry systems.
Sure.
And a lot more complex. So for this shape, indeed, we would start with the hull. You would imagine that the part is on a spinning table, so the robot is actually in one place only. It's welding, and you are creating the circle by spinning the build plate.
Oh, okay.
So you're on the extremities, or you're on the outside of the circle. It spins for 360 degrees. You have one layer, and then either you would move up one layer height, or for the pros, you do spiral slicing. You have one start point at the bottom, and one stop point at the top, and it's basically one continuous layer.
Okay.
So that's something we do. We have quite good control over that. So we print the hull. Then we do these rib structures. We have quite a few slicing strategies to control these overlaps and the individual movements. And with this, you have to imagine that the ideal welding position is top down. So we're continuously reorienting the part while printing these ribs. So it's 8-axis coordinated motion. And if you think about these infinite possibilities that a robot can be in one position already, think about how it works when everything rotates together. Then we're trying to find the best way to maintain velocity, because you do not want to slow down or speed up during your beat, because then you would have thicker or thinner welds.
Right.
So those non-planar slicing strategies, those are sort of how advanced it can get, but then you still have push and pull welding and tilt welding and maybe some tool yaw rolling. So there's quite a few parameters you can play around with our software package to do this.
Do you ever just like have a crazy idea and throw it in and try it? Because normally, okay, if we talk about printing on the consumer side, you know, I use a little bit of plastic to trial a piece of something, and I'm like, you know, I'm not wasting too much if it's a failure. But for you, like we're talking metal and welding, and there's a massive process to get something done. So do you get to experiment like that?
We do a lot of experimentation. A lot of our slicing strategies, they actually were pushed initially by people with crazy ideas, and many companies saying, no, we can't print that, and we were like, well, we do our own slicing, so let's try, and then we create these very weird algorithms that are able to do it, that then create quite complex parts. And if you would visit MX3D, you're very welcome in Amsterdam.
I would love to come to Amsterdam.
You'll see that our robot operators, our WAM engineers, each have their own Hall of Fame of various type of shapes and alloys and styles of welding. And of course, with experimenting, there's also sometimes failures. So
of course, there should be, right?
There's also some Hall of Fame where you can see how some experiments went wrong and what we learned from that. So it's pretty cool, yeah.
Some of the operators, though, I would imagine, take pride in what they're able to do. And I would imagine in that Hall of Fame, there's going to be some crazy examples of welding.
Yeah, there are, but the pride with the welding, there's so many facets to it. It could be like an alloy that is considered not weldable, and then when you even print a simple wall or a simple part, that could be a huge achievement, but for the outside world that might just look like a flange or this or that, but you know, in the welding world that's quite big. Then of course we have the shape language, which can be pretty extreme. For one, we got the bridge that you mentioned earlier. was quite a huge undertaking, 6,000 kilograms. For that we got the award from the American Welding Society. And there's not many bars in the world that got that award. The Panama
Sure.
Canal is one of them. So I think for the employees at the MX3D, various projects are like a badge of honor or a recognition of the work.
Yeah. Well, for those people, then, what's the schooling that they have? Like, what's their background? Because
Yeah.
there's going to be people that are like, whoa, how do I work for a company like this?
That's a good question. So obviously we're doing welding. So if you study welding, this is a good background to have when you come
Okay.
at MX3D. Obviously we care a lot about material quality, so material studies, very important. We're using robotics, so robotics is there, and then programming, be it robotics for tool pathing, for hardware systems, logging sensors, so it's a very
Oh,
digital
yeah.
field that we have.
It's crazy to think, though, because welding is a very analog legacy process. It's someone with a helmet on welding,
Yeah.
but you brought it into a digital age.
I would like to say, and I think I can confidently say, that our operators are sitting behind a computer monitoring multiple robots. So them wearing the welding helmet can happen.
Yeah,
But
oh, of course, of
typically
course.
they're just watching a screen where they're watching the control system do its job. So that job has changed, and that's maybe the future now.
Well, I think so, and I really like bringing legacy processes into an up-to-date sort of methodology. Like welding is something that we know works, and we just do it slightly differently, and it works out.
Yeah.
Sorry, it's hard to talk after all these Formnext days
I can
and going on an
imagine.
airplane and stuff. I've got one more kind of, I don't want to say silly question, but in making parts like this, do you ever get to make stuff that is just silly and fun? I know there's lots of propellers, oil and gas, you've got the ships and the nuclear stuff and these big things, but like, have you ever welded a Pokemon? Or
Yeah.
you know what I like?
Yeah.
Were you like, I'm gonna make a new pair of skis for myself? Or
We have had some 3D printed bicycles that were fully made with this process just to illustrate how fast we can print. So we can print a bicycle frame in a day. We have ridden those. Those have been featured on Discovery Channel
Yeah.
back in the day. We also did some huge sculptures. Some architects also look at this technology and they see a lot of potential. So we did a wolf sort of this tall. There's in Italy a whale on a 1-to-1 scale printed with our technology. There's sculptures, I think, in Mexico which hang on the ceiling, which are maybe 20 meters long. So
jeez.
if you go to our website, there's a subcategory art and you'll see a lot of
Really?
cool stuff there.
Well, this is a good opportunity because people are going to want to know more and they're going to want to see that art. So where do they go? Where do
They go to mx3d.com.
mx3d.com.
Yeah.
Okay. Dude, thank you. Good to
Thank
see
you.
you again.
Thank you for having
oh,
us.
man. Oh, that's where the part, I'll let you guys handle the part.
We just turn off.
You're gonna de-mic him.
Well, I'm just gonna do this because I'm gonna go.
Let's see. Is it taboo to have a lozenge on air?
Take it out of the frame.
Can you go in the snack drawer in the bag? Go for it.
You just lift it straight up and turn on its side. Do you know what I mean?
Yeah, we have to watch out for the table though.
All right.
There we go. Yeah, that zipper. Yeah, I'm gonna get a lozenge. Man, talking is tough. Thank you, Peter. Ricola. There we go.
Oh, there's an iPad over there.
Oh, the iPad. Oh, yeah. Thank you, Peter. Jonas, look after your voice, Joel. These are hard. It's true. It is true. Benchy on a bench, yeah. Benchy or nothing. Everybody wants a life-size Benchy. Sure, why not? Hydrate, hydrate, hydrate. Oh, yeah. I need a butter menthol, sure. Anything helps. I got some Ricola going right now. Oh yeah, come on in. Peter taped it up really well.
Hi, everybody.
Carbon's up next, getting everything set and put together. Morgan 3D Creative, Ricola are the best, that is true. How's everybody doing? There's been a lot of announcements at Formnext. A lot of stuff happened right as the stream started. Oh, Fisherman's Friend, they're fun. Let's see. And check and see. I know I had a video come out at 3 o'clock. It's doing all right. Oh. Love a Fisherman's Friend. Yeah, I've got some in my bag, but man, they are a bunch. Pez Liz looks like a fresh new hoodie. That's true. We call this the on-screen hoodie. Showarth, do we know when and if Prusa and Bondtech have a presentation today? I am unaware. I will try to find out. I'll try to find out. H2C announced but not available to the USA. Well, that's interesting. I was told different. Looking forward to hearing from Bondtech and Prusa. Who are you looking forward to speaking with the most? Everybody on this show. We've got some really cool guests coming up.
Always hot, but now you're hotter.
Lots of cool people. Yeah, everybody.
Ready for next guest?
Looks like a fresh new show, doing great. New tech. Yeah, I think we are. I'm gonna.
That table.
What do you mean? We seasoned it. There you go. I'm gonna hand the iPad off.
Oh, thank you, sir.
Next up is someone you've seen on the show, a friend of mine, someone awesome. Come on up, Andrew.
Hey, Joel.
Hey, Andrew.
I've got so much stuff.
Oh my gosh, bring it up. Okay,
I think
stand
there's
next to
actually a
me
little bit more.
so we can see you. Oh, is there more?
There's more. I think there's one more thing. We're working on it. We have so much stuff.
Oh, the helmet, of course.
Perfect.
There we go.
How you doing, Joel?
How you doing? Good to see
see
you.
you, yeah,
Good
yeah.
to see you. Wow. New stuff. First of all, okay, well, here, come closer so people can see you, just to make sure. And then, you're an application engineer.
Yeah, wow,
Right?
Great memory. Yes, exactly right.
And Carbon isn't like, it's not just like a 3D printer company. It's a
3D printing company.
It's a 3D,
yeah.
It's a company that uses 3D printing to solve problems.
Exactly.
And you are the application engineer, so you find the problems to solve with the 3D printing.
Yeah, exactly. So quick bit of background. So Carbon is a Silicon Valley company founded in 2013. We make 3D printers, 3D printing materials, and software to make 3D printed designs.
The
So a lot of
software is the
these-
big thing,
Yeah,
man.
the software is the cool, and that's the
Yeah.
thing. If I wind up talking about it, we're going to be here literally all day. But the software is super cool. Designing for the future is exciting. But we're really focused on applications. So Carbon is a company. We don't really release 3D printers every year. We're not releasing materials every year. We're really focused on driving applications and growth, especially in the consumer product space, which is a lot of what you're looking at here.
Yeah.
So these are all parts, the majority of which are available in stores. You can just go and buy a 3D printed thing on a shelf, like this shoe.
Like this shoe, okay. That is interesting. It feels interesting.
Yeah.
And this is produced with carbon technology, carbon materials.
That's right.
But laces.
It's got laces, yeah.
Yeah,
This is an update of the Climacool. So last year we launched the Climacool, or Adidas launched the Climacool, a project that it was really interesting. It's a fully 3D printed shoe, so it didn't have a tongue. It was like sort of like a foam runner. You would slide your foot into it.
I remember that.
And they just launched this one, and this one is available with a tongue. So it's more of a traditional shoe. It's also available in a couple different colorways. It's really interesting because the concept of a fully 3D printed shoe went from, hey, that might work eventually, to now it's surprisingly common, including you, Joel. You're wearing a pair of fully 3D printed shoes right now.
I've got David's D7s on, which are
Yeah.
cool. These Climacools are cool. Stuff we print at home is cool. It's crazy to see how many different 3D printed shoes now are available, even on home machines, right?
I've got a collection. I've got it's a big
I would
chunk of my
imagine you-
closet.
yeah,
It's like,
I would
you
imagine.
can see this gradient of everything from shoes that have 1 or 2 3D printed parts to shoes that are fully 3D printed like these.
But as an application engineer, though, how did you feel going from a fully 3D printed product that you slip into to something that uses other technology, other materials in order to exist?
Yeah, I feel fine about it. Yeah, it's one of these, like, I think 3D printing is a great tool, and so parts that are made with a 3D printer are fantastic for solving a specific problem. And
Yeah,
some
of course.
problems, like having laces or having a tongue, maybe 3D printers can solve that, or maybe there's a different way. And so for me, it's really about ultimately solving a problem. So I brought a bunch of stuff, and we can talk about some of the newer things we're working on.
Well, yeah, take me through. Well,
Yeah.
here, I'm gonna hand you that. Take me through it, man.
This one's a ton of fun. One more thing that's interesting about this printer for everybody at home. So this is actually made with a material that expands during the bake cycle. So our materials, we use a dual cure polyurethane. So
Okay.
we print a material, it's a resin-based process, and then it goes through a thermal bake. And in this case, when this part prints, it's like this big, and then during the bake process, it actually expands to full size.
Oh.
So you can fit more parts on a platform. They're shorter, so they print faster, and you wind up with a part that has this really nice sort of like airy surface feel from all that trapped air during the bake cycle.
Oh, so the bake cycle is actually, as it expands, there's air in there, and that's how you get this soft
Yep.
feel
Yeah, exactly.
to it. Oh. Oh, that's cool.
We're living in the future.
Yeah,
It's amazing.
that is cool.
So we've got a couple things here. We can probably start with this. This is one of my favorite examples. So this is actually a new helmet from Schutt. So this is a football helmet that uses an elastomeric material that's designed for energy damping on the inside.
Oh, each part has a thing.
Yep.
Like a designator, a rating.
Yeah, there's a bunch of different pads depending on the location of the part. And this material is strain rate sensitive. So for everybody who's familiar with oobleck, which is one of my favorite things to play with.
Oobleck is good.
If you mix
Cornstarch and water.
cornstarch and water, you
Yeah,
got it.
yeah.
You're a pro. And you get this awesome sort of like non-Newtonian fluid where if you pour it from a cup, it's sort of like water. It just kind of flows. But if you hit it with a hammer, it'll actually shatter into pieces and then flow. And then you have to clean your couch, and it's like a whole mess. But
Are
Oobleck
you
is
playing
really-
with
this
Oobleck on
is-
your couch?
It's a ton of fun. I don't know. It's fun. You put a little cup. So this material is similar. This is a strain rate sensitive material. So the intent is when you have a lot of energy that's being directed in a specific area, you want to be able to control that energy so all of the hard force doesn't go to the soft stuff on the inside of the helmet. And so by using this, we're able to get helmets that are rated really highly in the NFL Player Association. So I think we have the #1 rank right now in 2 or 3 of the top 5.
Really?
So these are helmet, like, I'm becoming a sports guy. I just saw a hockey game the other day and
Hey,
discovered this
cool.
is also used in hockey helmets. And now it's become a thing. Whenever I'm watching a sports game, I'm gonna look for these little vents, all these little cuts, and you'll see this 3D printed lattice on the field, which is a really fascinating application of 3D printing.
We were recently with the New Orleans Saints, and their head equipment manager, very pro 3D printing. He does these 3D printed pads, but also he's talking about full pads and their helmets are, and he's really excited about the future in this.
Yeah, it's a fantastic, especially for customizability, like you're able to actually take a scan and alter the geometry, you can alter the size, the shape, the type of lattice. It's a perfect fit for things like 3D printing.
Yeah.
My favorite project, back to the application engineering, is a project with a measured outcome, where we have something we're trying to solve. Because 3D printing, for 3D printing's sake, is awesome and it's a ton of fun, but it's really hard to get a product to market if its only novelty or its only real selling point is, hey, it's 3D printed.
Yeah.
It's like, well, it's 3D printed, but what does it do better? What does it do differently?
Well, in the business
Why
world, you've got
can't
KPIs, right? So
Yeah, exactly.
what's your KPI of this application?
Yep. So typically we're looking for a specific metric. It can survive some testing standard. You know, you can pass some amount of water through it, like this right here. This is a wheelchair cushion that was entirely 3D printed in one piece.
That's really cool. Oh man, that feels so good and soft.
It's pretty plush. So the idea here is you can tackle a lot of different problems. You have cleanability, you have airflow, you have like overall comfort, you can customize the zones. So it's just this really open field for 3D printing.
Can I ask you a question?
Of course.
So Make Good, they use bamboo machines and they're able to make cushions, but they're using standard infills available in order to make them. But this process differs in a way, right? Can you talk about that a little bit?
Yeah, I actually just found out about Make Good recently, so this is definitely on my list of things to do some research into. But yeah, this is a resin-based process, so we're actually taking the part and it's coming out of a vat of resin before going through that secondary thermal bake cycle.
Yeah.
So for this was made using our design engine software, so you can see this sort of repeating structure, and that's called a lattice. And we're able to really control the zones
Yes.
of that lattice. And
Yep.
we can say, well, I want it to be really stiff here, I want it to be really soft here, I want the lattice to have, again, there's something that we're trying to solve for. And
Right.
being able to control that in software is just amazing.
Yeah, I agree. I think both technologies are cool, but this is like that advanced version where you have all of these knobs to turn in order to customize the experience anywhere.
Yeah, exactly. So
That's cool.
It's just it's a sort of a perfect fit for 3D printing.
Is it? Wait. It's comfortable.
This is, I think,
That's
every
really comfortable.
office chair in our building
Oh, I
has
bet.
something like this.
I
Every
bet.
time that we have one of these parts that goes out, there's a line of people who want to try it out.
Of course.
So speaking of customizability,
What do we got here?
so we hinted at this last year, and we talked about this a little bit the last time I was on the show, and this finally arrived. So this is a 3D printed bike saddle.
Oh yeah! You're
That
an
was
avid
made-
bicycle person,
Yeah,
so
exactly.
it's
So-
really cool to see this.
So this is actually a custom bike saddle that was made by Physique. It's called the 1-to-1. And so this actually features a zonal lattice that is made using, and you can see a little heat map. So this is using real pressure data. So I sat down on a bike and I rode it a bunch, and then
Can I
this is the,
Can I just say, it measured your butt.
it measured my butt. 100%, that's exactly what it did. And then we take that data and we print the saddle with it. And what's
That's really cool.
The process for this, it was originally intended, stuff like this exists for high-end athletes, it exists
course.
for consumers. And the #1 rider who finished the Tour de France this year, Tadej Pogacar, was actually riding this saddle made for him. So he had an exact one of these made for
Really?
him. Yeah.
Well then, if we talk about the 3D printing aspect of it, is it less expensive?
Can you move this for a little bit?
Oh, smart.
Is it less expensive than a traditional manufactured, or is it? I know it's providing more comfort and a better experience, but what is the price point for this compared to a traditionally manufactured high-end saddle?
So I'm gonna do my best with the numbers here. I think a typical saddle like this would be about $180. I think if you got a foam version for like a high-end like road bike saddle, something carbon fiber, 180 to 200-ish. The 3D printed one started around 300.
Well, that's not bad.
It's not an astronomical jump. Thank you.
No, I'm good for now. Thank you, though.
So the idea here is the customization is really kind of that key element of trying to find something that's a good fit.
Well, and I understand that there's always going to be a premium for having something bespoke and custom. But again, like for someone that is a cyclist, someone who is riding often or has high-end requirements, a 33% jump in a saddle isn't really that bad, all things considered, because it could provide them more comfort, or perhaps they can go longer,
Sure.
or so there's really that, like you said, there's that measurability.
Yeah, and you're also looking at, this is where the material properties are kind of interesting. So this is an energy return material. This is EPU41. So the idea is when you squeeze it, it bounces back.
May I?
Pretty straightforward. Sort of the opposite of an energy damping material, where when you squeeze it, it's more like memory foam. It kind of takes a minute to return.
Yeah, of course, but this rebounds.
Exactly. And so typically for a saddle, you want something that's going to have a high rebound, because otherwise you just sort of sink through a soft layer of foam.
Right,
and
you
then
don't
you're
want to sit
sitting
on a
hard-
couch.
Yeah, exactly. And then you wind up with a fairly uncomfortable ride.
Yeah.
And so this was really exciting. This launched last year. I got mine. This is actually a replica of mine. This isn't the one that I ride every day.
Really?
I had two made, and I have put about 2,000 kilometers.
Is that your
on it.
scan?
That's my cheek data.
Oh.
So yeah, it's exciting. This is a really cool product, and to me, it's a perfect representation of finding things that 3D printing is really good at, finding problems that can't be solved conventionally, and applying an additive process to it. And it's really,
Right.
this is where everybody wins.
Well, that's again, I was talking to Christoph from Masago at the very beginning, and that was one of his just things that he wants to see more of is small and medium businesses using 3D printing to solve a legacy problem.
Yeah.
And you're taking a very legacy product and you're using 3D printing to make it better for the user.
Yeah, exactly. And so this is like the bike saddle is, one step removed from the bike, which is one step removed from the wheel. So these are old technologies.
Well, the people that were on
like,
before you, MX3D, made the bike. You can make the saddle for their bike because you're not going to have a metal saddle.
That would not be ideal. There are challenges there for sure. But yeah, so this is exciting. To me, this is like a perfect culmination of what is 3D printing good at? Like, what are the problems that we can solve? And this is a good one.
So in doing this, is it okay if I ask one more question about this?
Yeah, please.
Because I think you like this a lot.
I do.
So in doing this, was there something along the process where you're like, oh, if this works, it means I can do this?
Yeah, and that's a really great question. And so the answer is absolutely. We have an automated pipeline where you go from importing data, so some form of pressure data, geometry data, something like that, comes in on one end, and on the other end, a product gets sent to a printer and printed. So somebody doesn't have to sort of sit there and like name the file saddle.stl. They're not having to lay it out on a platform. They're kind of taking advantage of some automation. So
Okay.
Last year, when we started doing a lot more custom projects like this, we had a goal of 1 million custom parts per month, every month. And as of last month, we are officially at 920,000 custom parts per month. So we're almost there, we're so
Dude.
close. So this is a perfect example of from this saddle, there's that giant pipeline of now anywhere where you can import any kind of data, pressure data, geometry, and you want to print something somewhere else, instant process.
Dude,
so the pipeline was kind of, it's like we got the saddle, but then the other part was all fun.
That is so cool.
Okay, so we're talking about small, medium businesses, so this is actually an excellent segue.
Oh, I did my best. Yeah,
You did great.
Yeah, let's put that over there. Okay.
So this is a soccer cleat guard from a company called Hypesole.
A
And
what?
so
Wait, a what?
A soccer cleat guard. So you actually put your soccer cleats. Soccer cleats are difficult to put on and off.
Yeah.
They're dirty. You wear them on a field. Then you have to go.
Oh, I've had kids that played soccer. I'm very, very familiar.
You've cleaned out the back seat of the car. Like,
I was
this is
just going to
the
say,
whole
the
thing.
inside of my minivan was mud for a while.
It's a real problem. And so this was actually an entrepreneur who came to us with this idea of this entire product category of soccer cleat guard. And so can we 3D print something that can go over a cleat that you can take on and off with one strap, print it in one piece, and the target audience is exactly people like you who want their children playing soccer, or maybe they play soccer, but they don't necessarily want to be vacuuming mud out of a carpet.
What a cool idea.
Yeah, and so this was, they came to us with this concept, our application engineering team. We have an application engineer named Kelsey Reed who worked on this and did the design and brought this thing to life. It went to production, and now this is actually, if you search soccer cleat guard, this is the first thing that pops up.
That's cool. And so with this, there's no pressure data.
Correct, yeah.
That you need to take advantage of.
This is done by size. So this one is a stock product. It's available by shoe size. So you just tell the website what size shoe you are, what cleat you are, and this is what pops up.
And something like this, was this available via another manufacturing method? This is a new thing.
This is a new product category, so this is an entirely new thing. And so it's one of my favorite, it's a perfect example of small business success story. So you have somebody who has an idea, they maybe don't really have access to a 3D printer, they don't have access to design technology, and they can articulate what they're trying to accomplish.
Cool.
So back to that measurable outcome, and then you want to do something like this.
I love this, and it's why I love 3D printing, is being able to solve the problems that you didn't know existed.
Yeah. Yeah, so
and as an application engineer, I mean,
this is all day.
That's like, yeah. Oh, cool.
So, yeah,
all right,
so this
well,
is a fun one. And then we also have, speaking of small businesses, so this is the Phoenix hipwear pad. So this is actually a pair of shorts.
Okay.
Designed for women with osteoporosis. Their bones are fairly brittle, and so active living can be a challenge. So this design right here is made of that same strain rate sensitive material. So this is designed to take an impact. So you can wear it stitched into the side of your pants. And the idea is this will actually protect your hips from a fall.
Hit me. Harder.
And it feels great. So the idea here is this is really designed to try and keep somebody who's used to having an active lifestyle, but may not necessarily be confident enough to tackle sports that they used to enjoy for fear of getting hurt. And so this is something that, again, a product category where somebody had a concept and they kind of explored this idea of using different foams and different materials, and we thought, well, we can make something that's conformal so it sort of moves with you, and then 3D print it out.
It's just really cool to be able to talk about things now where people can come up with experiments in products using varying densities of foam, and they don't have to go source this block of foam. They can go to you and be like, I have this idea, and using the tools available, you can make varying foam levels, and that's great.
Yeah, so we call it zonal density, and it's exactly what you're describing. It's taking problems that are, hey, this piece used to be made out of 6 different foams or 6 different pieces or thicknesses. Can we just do all this design digitally? Kind of analogous to if you have a home printer, changing the infill amount on a TPU print and saying, I want one area to have a lower infill amount because I want it to be maybe a little softer.
Right, but I mean, if I was going to use Prusa Slicer, I'd have to set a weird change block and modify and stuff like that. But
it can be a challenge. So that's where our software design engine was basically born out of. Is there an easier, more repeatable way to do this? And so it's where I spend the majority of my time designing products.
Oh, we could talk forever. But you get one more. You get one more thing to show me.
Okay, so I have one more thing. This is a fashion footwear launch for Alexander Wang, a name that I'm told is very prominent in the fashion footwear industry. And this is a 2-part kitten heel. So this is actually an elastomeric material. So this is a rubber-like on top. And then on the bottom, you have a rigid polyurethane that's bonded to it.
But this is printed as well.
They're both printed together, yeah. And so they're printed in that thermal bake process. The two are permanently joined.
But wait a minute. This feels like a...
It's rigid, yeah. Yep, so it's a rigid part and then an elastomeric part, and the two are bonded together.
David knows a lot of shoe people. Look at that.
Oh, hey, it's Alexander Wang.
Yeah, see, he caught it immediately.
Is it really?
Yeah, it is.
Yeah, it is. Yeah, yeah. And producer David was like, "Yeah, that's Alexander Wayne."
He knew
yeah,
immediately.
that was
Perfect.
awesome. That's cool, man. Just being able to.
I like it.
So then, I'm sorry. One more question. I have to do it. So then, what's the roadmap for Carbon over the next 12 to 24 months? Or, more specifically, what are you excited to be working on or developing that you can talk about over the next 12 to 24 months?
I have the most fun and most unfun answer ever. It's the same as the last 12 to 24 months, which is applications. That has been our focus for years, and it is, to me, a path to sustainability in additive manufacturing.
Okay.
I think 3D printing companies, they really suffer because there's a lot of hype and there's a lot of excitement around new machines, but the reality is a lot of these parts and a lot of things that people are buying, they're buying them based on the merit of the product. So being able to continue to refine product categories, make parts that do things that you can't do with traditional materials, that's what's really exciting to me. And I love walking into a store and seeing something 3D printed and saying, oh, hey, I see a layer line.
It's happening more and more,
yeah,
isn't
it
it?
happens all the time now, which is great.
Dude, thank you so
Joel,
much.
it's great seeing you.
It's always good having you on, man. I'm really happy about this. And I can't wait for next year when you show me more cool stuff.
Awesome. I look forward to it. See you later, Joel. Oh, that was crisp.
Don't forget your water. Look at all this stuff. I'll put the shoe back.
Appreciate it.
Because,
Let me turn you off first.
Gotta make sure the shoe's good, Are you D, Mike, and Andrew?
I am, and there's people that want to say hi.
Okay. I like people saying hi.
Todd, go run on stage and say hi.
It's hot, running on stage and saying hi behind the scenes.
There you go.
Oh, hey
Oh my
there.
God. Okay,
Who's
everybody
here?
come on up.
Who
Come on
is
up.
here?
Oh my
Hello.
gosh, look at these guys. Look at these guys, dude. Look at this.
So we can share the
there
microphone.
we go. There we go. There we
We
go.
have two microphones here.
Yeah, we got two. So you have to yell into my chest if you
All right.
want.
Hello, everyone.
How is everything going?
Everything's going great, man. I haven't gotten a chance to see a lot of the show, but I saw you guys earlier and I waved and then you walked away from me.
Yeah, of course. Yeah, we want, yeah. Sorry about
But you couldn't get in the press area is what it was, right?
that.
Yeah.
Because we haven't got cool stickers.
Not yet.
Not yet.
Not yet.
That's why.
I don't know. You need a blue hoodie. Apparently they let you in any bar.
All right. We're gonna try.
We need a little smiley face next
Yeah,
to
a little smiley face next to it. Yeah. What do you guys got going for the rest of the day? What does
of the day.
Formnext look like you for What does Formnext on a Tuesday look like for you?
On a Tuesday.
Hectic. Really hectic.
Closer to your face.
Closer to my face. It's not that I don't know how to use a mic. Apparently.
Just
I'll have
make
mic.
use of the approximation effect.
Okay.
And it sounds better.
ASMR sounds. I'm tired, I'm sorry.
That's all right.
I'm very tired today. So I'm very looking forward to tomorrow to be a bit more, to get more sleep.
Oh, there you go.
tonight.
Okay.
Yeah.
Okay. How about you, Jean?
I don't think I will get enough sleep, but I am excited
No,
for
you're not
tomorrow.
going to get any sleep.
No.
No, not even a little
But
bit.
tomorrow I brought a 3D printer on the Prusa booth.
Oh, wait.
And I wanted to have it printing today, but
Yeah.
we had some technical issues. So tomorrow we are going to solve that and have it actually print on
Really?
Yeah.
Tomorrow?
Yeah.
Okay.
That's the
I'm going to
plan.
want to see that. Okay. Jonathan?
I'm just exploring and seeing the best that can be out there.
That's so
There's-
generic.
Well, it's true because I didn't know I was coming here till 2 days ago.
Oh,
So,
really?
really, I had
Oh,
no idea.
all right.
I just sort of rocked up, and now I'm just exploring everything that's out there.
A heck of a show to come to without knowing it,
Yeah, it is, but at the same time, people want to talk, and apparently that's enough to pull me in.
Well, you all go have a great time. I appreciate you coming by.
Have a good one.
Oh, man. Good to
We're
see
gonna
you.
steal
I'll
the
see you
mic.
tomorrow.
We're gonna take the mic with us.
Oh, you take it? Okay.
Yeah,
Mike's
back in
going
the-
on an
in the
adventure.
backstage. We're gonna share some
I guess some details. All right.
hidden insights.
That was fun. You never know who's going to stop by the live stream, apparently. And apparently Sean's got that new printer that he was working on, the new heads on the Prusa XL. I believe it's at the Prusa booth. So tomorrow it's going to be printing. And that is really exciting because I want to see that. Whew. Hey, Peter, can you give me another throat lozenge just in case? I want to make sure. I appreciate it. Ooh, we're miking up the next guest. Things are going on. Oh, man. Oh, yeah, the iPad. Let's see it. Thank you, dude. I appreciate that. Keychains. I love watching proper printing crazy ideas. I do too. John S. Did John bring his XL? He sure did. Thank you, sir. He sounds confident. We'll be printing tomorrow. Yes. No, I'm good for now. I love seeing a group of YouTubers I watch. That's right. And the Ricola goes in. Let's see. Almost had it. Oh. Maker Viking said, hi guys. I think he saw it. Kurt Shaluzadi. Who's next? David, come here.
Yeah, hey, what's up, Joel?
Hey, who's
Hi,
next?
Joel.
Yeah, who's next?
These lovely gentlemen right here from Amontis.
Amontis. Ooh, I'm excited. All right.
Because we're bringing up the machine. We're going to do some printing.
Are we?
Well, something.
All right, all right.
Let's go for it.
Come on up. Oh, we got stuff. Okay. Oh, more stuff. Yep.
Hi, I'm Felix.
You're what?
Felix.
Felix.
Yes.
I'm Joel. Oh, and you got the mic. Come on up. Come on up. Come on up. So the camera can see you. All right, Felix. There's some very interesting things on the table here that and there's more coming.
Oh, yes.
Is that broccoli?
Yes, that's broccoli. That's real. It was real
Oh,
broccoli.
and this is a bunch of benchies.
It's a whole amount of benchies.
And more parts are coming. And he's picking up more parts.
Yes.
All right, well, Felix, what? Oh, okay, good. Okay, I think there's a little bit of a pause here. All right,
Yeah.
Felix, I'm staring at a lot of metal parts here. Can you kind of take me through what's going on?
Sure. So basically, those parts are created using our desktop replicator. It's a metal replicator, so you take a filament print, and then the filament print is turned into a metal part.
What?
So
Wait, what?
Yes.
You have a filament print?
Yes.
Like a benchy. Let's just take, if I had a benchy, not the whole benchy, but just one benchy.
Yeah.
I would put it in your machine,
Yes.
and it would turn that benchy into a metal part.
That is true. So you first,
Okay, you're going to need to tell me a lot more about this because this sounds incredible.
and later actually I can show you the process in the machine. Yeah. But first, how it works is you take your filament print,
Okay.
and then you create a casting mold. We have a system for that as well. I will show you later.
Okay.
And then this filament print gets covered in our mold material, put in our machine, and then our machine heats it up to 700 degrees Celsius. And then that pattern burns away, and you get a mold cavity. That is the same shape as the part.
Is this lost PLA casting?
So basically, yes.
Oh,
Yeah,
okay,
look.
but you've automated it.
Yes, exactly.
That's cool. Wow. I don't think a lot of people out there, I don't think they realize what's possible because lost PLA casting is cool. And to be able to automate that process really gives more people the ability to now turn these shapes that they're very familiar with into metal shapes. So how is it done?
Well, first take the part, then you create the mold.
Yeah.
And our machine burns away the part.
No, I know that, but
yeah.
like you've automated the mold creation.
Yes, we automated the mold creation, so maybe bring that on. Yeah. So.
Like that's an amazing thing in itself.
So first, we got our benchy here.
Okay. Now, how did you attach that? Is that just melted wax?
This is just melted wax, yes.
Really?
Yeah,
Okay.
Just stick it on there.
Can I hold that for a sec?
Yeah.
Peter, I want to make sure you can see all this. So this is a benchy. I'm very familiar with this. I've printed many of them, as I'm sure you have too.
Yeah.
Yeah. Okay. And it's held to this part with melted wax.
Yes.
And this is this wax in here?
This is just silicone rubber, just to hold it. You can just pop it in and that. So it just goes in like this.
Oh, I was being really delicate with it.
Yeah. Just put it in.
Okay.
And yeah.
Okay, next part.
Then we take this ring, just screw it on here.
Why not hold? Oh, there we go. You got purchase.
And now we need to add some mold material.
And you happen to have some.
Yeah. We pre-package our mold material in water-soluble bags. Just put it in here. Close that. And then you just add water, and that's it. Then you shake it and pour it in like a protein shake, basically.
Wait. What?
Yeah. So let's do it.
How much water do you add?
This is 300 milliliters. of
Okay.
water. Yeah.
In a water-soluble bag.
And now the bag dissolves.
Felix, this is so cool.
I close it. Make sure that it's actually airtight.
Oh,
And
yeah.
then just shake it.
Oh my
And
gosh.
now it's already dissolved. So now it's
Wait,
done.
it was like that.
Yes, like this. Yeah.
Can I?
Yeah. So it's already gone.
Oh my gosh. Just like that.
Yes.
Like that was it.
Yes, that's it.
I am shocked. That was so cool.
Yeah, make sure to get the chemistry right so that it just works. You
Yeah.
can shake it for like 20 seconds and then after that you unscrew the cap and just pour it in. Unscrew
That's it?
That's it. Just pour it in, like so. And before pouring, you can let it sit for a minute and all the air bubbles will go to the top.
Okay.
Do you have any bubbles? Yeah.
Like, do I need to? Do I tap it a little bit to get the bubbles out?
You
Or?
can do that. You can tap it or put it in a vibrating table if you want to. But if you just let it sit for some minutes, it will dissolve by itself.
Okay.
And then you can add this on top. And then you can flip it around in case you have very complex parts to make sure that there are no
Oh,
air
I
voids.
see. I see. Okay.
Yeah.
Okay.
And then after 45 minutes, the part is it's all set. And then we have the mold over here. Then
Oh,
it
wait a
looks
minute.
like
Wait a minute. So at this point, this is done,
This is done.
and you just set it aside. You
Set
go
it-
make yourself breakfast, and you're good.
Do something else. And then once it's finished, you just unscrew it. And then you can press here and it opens just like mold for cake. Then just for the...
Okay. Okay.
Then you have this thing here.
Can I hold it?
Yeah, can hold it. This is...
Oh, this is legit. And look at, there's that little wax piece right there. So then that PLA benchy and that wax tip is all embedded within this
Yes.
material. And this sat for at least 45 minutes, probably longer,
Yes.
is my guess.
No, it's this one longer now, but yeah, 45 minutes, and
Yeah.
we can adjust it, so it's not an issue. We can also make it down to 15 minutes if you want to, so it's
Oh, just-
adjustable. Yeah.
oh,
Change the
okay.
chemistry up a little bit.
Okay, so this is set. So what's the next step
The
from
next
here?
step is we load in our machine, and it's that we bring it on after we saw the parts.
Okay.
Yeah, should we bring it on right now?
I don't know. Is it time?
Yeah, let's do it.
Should
yeah.
we? Okay.
Maybe, I don't know.
Yeah,
You have to
okay.
process, yeah.
Oh, well, why don't we move the whole table? Or you want to put the machine on the table? We'll use the small one.
Yeah, we can put it on here, yeah. Just,
You want to put it on here?
yeah, let's
Are
do
you
it.
sure? Well, it's going to block the shot.
Is it?
Well, if we put it at the end, we can be on either side. Or
Just going to move the table.
Yeah.
And then we'll put a smaller table here.
okay.
Yeah, so if you hold the edge, the lid is not sturdy. So it's... Okay, we're going to do this over here. There you go, so easy.
I'm just holding on to this. I'm keeping this nice and safe.
Yeah, there we go. It's right here. You guys got it? Oof. Boys.
This is so cool. We can scoot the table back if we need to.
Yeah.
Yeah. You want to move the table back a little, Peter?
You back? Yep.
If you lift it, I'll move the table. You lift the box, I'll move the table. All right. Okay, good.
There we go. I got a thumbs up from Peter.
You got your power here.
David, do you know how to use a European plug?
Yes, I was just making sure.
Okay, because I didn't.
Okay, hold on, let me get out of the way.
Okay, so I see a screen.
Yes.
The screen is on.
And here,
It's got there's a little SD card in here.
yes. The stick card is for the programs, because you can cast different kinds of metal, for example.
Okay.
You can cast aluminum, zinc alloys, or copper, silver alloys, or even gold with it.
Wow. Really?
Yeah.
Okay. What are the next steps, Felix?
So, you press a button, then the doors unlock,
Oh.
and you just put the mold in here. I made a bigger mold inside here, because you can also make bigger molds, so just take the mold, put it
Oh
in.
wow, that's a much bigger mold.
Yeah. You have even larger ones. Put it inside here.
Does it matter where you put it?
It doesn't really matter. Just center it and then it's fine.
Really?
Yeah.
Okay. It's surprising how easy that is.
Yeah. And then just close the door. And now here, this area is heated up to 700 degrees Celsius, so the pattern burns away.
Got it.
And then up here, we add the raw metal. Just some chunks of metal, just some piece of scrap metal. You can also use scrap.
What is this,
actually.
aluminum?
This is aluminum, yeah.
This is just a chunk of aluminum.
Yes,
just a chunk. Okay. Oh, and you literally just have chunks of aluminum down in, what would that be called?
That is the crucible.
That is the crucible right there.
Crucible, yeah.
There's just chunks of aluminum in so a bunch of these down here.
Just put it in and then
okay.
you close it. And this is a vacuum chamber. So now the aluminum is melted under vacuum and casted under vacuum. And that way you can get really, really fine details. Because for example, here, this was a real flower. And we just, instead of a bench, you can also put it in a real flower, and then you get an exact replica of the real flower.
Oh, because you can put in an organic material because it's going to burn it out. So this was a real flower. Peter, are you on this? Yeah? Okay. That was a real flower that was burned out and made metal.
You want to, you can also use wood. For example, here this was carved out of wood, and then we created a metal.
Here, hold that flower. Okay. That is, okay. Now, are we actually going to melt stuff right now?
No, the process actually takes 18 hours.
Oh, okay, good. Okay, I was like,
parts, it takes like 8 hours.
Yeah.
So just overnight, just print it and then let that machine run overnight. And to make sure that you can actually use it on your desk, we have a catalytic converter integrated. So all exhaust fumes are heated up and then converted so that there's no smell.
This is literally a desktop casting machine.
Yes.
This is amazing. This is amazing. To be able to make those shapes. Like, look at this. So this is going to be that piece of wax.
Yes.
And then you just trim that off.
This is it. No.
But like just with like some sort of like a saw.
Just
cut it off. Yeah.
And this is it.
But then you're left with like this is really good.
And the cool thing is you can also make very, very delicate parts if you want to. For example, this here is made out of aircraft aluminum. So with 0.4 millimeter wall thickness, you can make extremely delicate parts as well.
Doesn't weigh anything.
Yeah.
Oh, I see. And then there's
a wing segment.
Yeah. So then that would, or whatever, you know, the wing would have been attached. Have you made a full like RC airplane?
We are thinking about it.
Yeah?
We didn't finish it in time, but we have the designs for it, so we would really like to complete that as well. And yeah, those are actually some metal flexor structures. You can also make flexible parts if you want to, because the aluminum is so strong.
Here, there's so many parts. I don't have that many hands.
That is.
Okay. Felix, this is by far one of the coolest things I've seen, because the process of casting just itself can be frightening to people. Having to melt metal, especially if someone's in like an apartment.
Yes.
But you're running on a standard outlet here.
It's just a standard power outlet. And that's also how we came up with the idea, because we're running a standard casting system and realized that the parts are super cool, but it's hard to do in a household environment.
Yeah.
So we then tried to figure out how to solve all those issues we have with casting at home and somehow make it feasible. You can run in any office, home, anywhere you want to.
That's so cool. Okay, well, is this available? Is this something that people can buy now?
Yes, we are selling those machines right now to industry clients, and we already delivered machines, and now also collecting orders.
What does it cost? Can you tell me?
I can't. Right now we're focusing on industry clients. I can't give exact price on that machine.
Okay, that's fair.
But we are also, our booth, we also have a smaller version of that machine, just as a mock-up. And if there's enough interest in this smaller version, we can make it possible that consumers and small jewelry stores can also have that machine in-house. So that's totally feasible. And
that's really cool.
We'd like to make it happen.
Oh man, Felix, thank you so much for bringing this by. This is so cool. People are going to be interested in this. And like, it's almost, not yet, but it's almost a home machine. Like we're almost there.
Yes.
I know industry first, but people might be able to do this in their house with your machine soon.
Yes, that is true.
Oh, good. Okay. Thank you, dude.
Thank you.
Thank you very much. David, be careful. Here, I'll help you get some parts off. I'll let you take these. How cool is that? Jeez. Oh, here. We got to take this. Do you want to take that one out?
Oh, you can leave it in there.
Okay.
Cutting power?
Yep.
Next is EOS.
Okay. Do we have a minute, or do you want me to? Okay. Jonathan, come here.
How you doing, boss man?
I'm doing good. Here, jump up, jump up.
You're still on your feet, man.
I know, dude. That's good.
How's your voice?
Good to see you. Ricola. Here, you got a shout on my chest. How's Formnext?
Fantastic.
You got a shout on my chest because this is where my mic is.
Fantastic.
Okay. Oh, David's got you a mic. There you go.
Hold on. Producer David producing.
Yeah, I've got a minute.
There we go. Yeah, we got a minute.
Got a minute, and then got some guests.
Yep.
All right.
Yeah, we're good. I just wanted to say hi.
All right,
Bring it
man.
up.
Yeah,
I'm glad you made it.
Mic'd up. Yeah, you too, man.
It was it was okay. Well, coming from the, let's see, your flight is much shorter than mine, right?
5 hours.
I'm 12. It's a bit much.
The amount of caffeine you must be on.
It's a lot. It's a lot. You originally weren't going to be here, right? Didn't you get a last minute sort of trip?
You're thinking of other Jonathan.
Other John, I got the last trip. Have you had this plan in the works for a long time?
6 months, man.
Was it really? Oh, okay.
Yeah.
That must have been
This is the easy one for me.
This
is so easy compared to China. This is so
This is
easy.
nothing. Oh, here, bring the table in.
Look
Yeah.
at that.
Look at it. Got the strikes.
I didn't know that I was coming on the live stream at all.
No, no one does. No one expects it.
No one expects.
All right. What's the coolest thing you've seen so far?
Ooh, that's.
It's not binding, man. You can say whatever you want.
You know what? This is the first time I've seen the Bondtech Index in person.
Yeah?
Ever.
It's cool, isn't it? Like, it's
Very
slick.
cool. It's very cool. And I saw someone who came up with a similar thing. The Swiss DB guy has a similar thing, different way solving the same problem, using like it raises all the tools. That was pretty cool.
Oh, that's cool.
So it's like Bondtech, and we were debating at Bondtech if it's gonna like infringe on IP, but it uses a switch to lift the tools up, in.
Oh, okay.
Yeah.
Oh, that's fun.
Yeah.
All right. Well, dude, good to see you.
Yeah, likewise.
Thanks
man.
for jumping on here real
My
quick.
pleasure.
Whoa.
That was almost a very
Here,
expensive
you hold that.
visit.
I'm gonna recover that.
Yeah. Good to see you, man.
Go have fun.
All right. Take care.
All right, I'm gonna trade you that for some water.
Oh, thank you, dude. Oh my goodness. Anybody jumps on. Anybody's around here. Everybody, if you have something to drink next to you, raise it up. Cheers. Stay hydrated. All right. David, are we moving the table next, or are we good? Okay. Okay. Well, until, yeah. Yep. How's everybody doing out there? I hope doing well. My voice is staying true. This is pretty good. Peter, how's it going over there? Yeah, Peter gave me the A-OK sign. Good. Oh, we are, let's see, what time is it? We have an hour left of the stream. Oh my gosh, we have an hour left. An hour with some amazing guests. It's gonna be fun. Will my voice hold out? We'll see. What? Oh, I should, well, I don't know if we'll have time. Maybe. I don't know. David, what's our ETA? Do I need the iPad, or are we almost good? All right, good. No iPad. Next up, we've got something pretty cool. Come on up. Hey, I'm Joel.
Hi, Joel. Nice to meet you, Vincenzo.
What's your name?
Vincenzo.
Vincento.
Yes, thanks a lot.
Vincento?
Vincenzo. With Z.
Vincent. Vincenzo.
But more or less, yeah, fine.
Vincent.
You made it.
And you're from EOS,
Yes,
famously known for printing
I hope so.
all sorts of metals.
Yes,
Yeah.
we do polymer and metals, both of us.
Polymers and metals, but I'm very familiar with the metal side.
Really?
Well, familiar to know that you print lots of metals.
We try. We try.
My buddy Joel Sam.
Ah, okay.
Yeah, we got to travel down and hang out with him for a bit and,
Okay.
and see some metals printed. And
Yeah,
so
nice.
that
What
was
did you
fun.
design, print something by yourself?
We printed, I didn't design anything, but we printed a small motor, I
Okay,
believe, and we
okay.
did it out of copper.
Okay.
I think we showed off copper printing,
Okay.
which was kind of interesting.
Yeah, not
What do
bad.
you have here?
Here you have one experiment. Let's say not experiments, it's a really project.
Okay.
It's called the Vaporizer.
Okay.
It's from a company, it's called IKM, company from Norway, UK, it's a bit all over the world. And it's from the oil and gas industry.
Oh.
And this device, it's basically installed on a ship that carry LNG, liquid and natural gas.
Oh, okay, I see.
Yes.
Oh, so the ship has gone out and collected it in tanks.
Exactly,
and-
collect them in tanks and then move it to the shore, to the
Yeah.
closest shore and so on, or wherever it needs to be delivered. And this device basically collects the gas from these two pipes here at minus 162 degrees Celsius. It's, let's say, liquid gas, really cold. And then thanks to these channels that they go here, that they have been, let's say, topology optimized via an advanced software from a company called TOFX. It's a startup actually, really cool guys. It comes here, does this sort of, let's say, channels here. This one just half.
This tiny little pathway
This tiny little path, yeah.
Okay.
It does, let's say, this sort of little spiral here, and from liquid it becomes gaseous at plus 60 degrees and goes to this exit here. The cool thing is that this object helps to measure more properly the gas composition in these, let's say, big ships that carry the gas.
Oh.
And with the, let's say, round about 4 times better than the conventional manufactured one. And the cool
4 times
four
better?
times better. 4 times better. And the very cool thing is that this one helps to save millions of euro in a single carry of gas. And this one will go basically in serial production.
So a ship carrying liquid and natural gas.
Exactly.
Millions of euros can be saved in the in the processing of
In
that.
the process of measuring, to
of that
measure the
measure.
chemical composition
Yeah.
to see if it's really fine or not. Particularly because, you see, the environmental temperature, they can have an effect on the amount of gas that you
Okay.
can carry back and forth. And this one, thanks to this device, the measurements are really more accurate. There is less noises in the measurements, and it works great. It works really great.
Wow, and the reason it works great is because of the optimizations you've done,
For
right?
the optimization, and the cool thing of this one, considering the complexity of the design, the only way to manufacture it is just with 3D printing. So it can be manufactured just with our technology on, let's say, on our machines, and it works great. Basically, if in the past you had a few weeks of lead time to produce one of these,
Right, because it would have to be milled, correct?
exactly, it would have been milled and would have been milled from a big block of aluminum. In this case, it has been printed with our machine with a special process pyramid. You can see the surface quality is quite great. And,
yeah, it's fantastic. Well, here, let me just do that.
And you
That's
can,
the surface quality of the machine,
exactly,
right?
Yeah, exactly. It says build, no kind of surface treatment done. And you can
Wait, that's from the, so no post processing,
no, it says
surface.
build. It says build. Yeah,
Oh.
it says build.
That's good.
Yeah,
That's really good.
it's really good. Yeah, and we did a trick on the printing process where basically with a machine you can print 9 of them in 90 hours. So for each one of them, waiting a lead time of a few weeks, you can get each one of these in around about 10 hours.
That's amazing.
Yeah.
That's amazing.
I got to interrupt real quick. We have another guest from EOS.
Yes.
Are you at a good stopping point? You have a couple more things you want to get across before?
Just a couple of things and
Okay,
then
yeah. 'Cause we only have a certain amount of time for EOS. But we have to get something else
Okay.
to show.
Yeah. Okay, yeah.
Let's see. I will make last thing. I took you a present.
A present?
Here I have a, let's say, a mystery pocket. I have 2 presents. First one, it's a 3D printed bottle opener in titanium.
Ooh, I could absolutely. Here, hand me a bottle of water there, Peter.
Yeah, let's try it.
Please. I will. There we go. Yeah. I will. Yeah. Okay, we're going to test it right now.
Yes.
Wait.
I'm waiting. Let me know when you're on it.
Yes, great.
Yeah, okay.
And this one, it's great. You can keep near your keychain. Works amazing.
Yeah, absolutely.
And it's super easy to carry. I have it with my keychain. So in Germany, if you are in an emergency to open a beer, that's the right one.
Which is it. Okay. Perfect.
And last one, I know nowadays it's not really fancy anymore riding with pens, but this one, it's a 3D printed pens in titanium.
Oh, wow. This is...
Many people, they told me that it reminds the Lord of the Rings.
Yeah, I can see that.
It's kind of a fancy elfic design.
It's a very ornate design.
Exactly.
Yeah.
And this one, you can open it like this. Here, you remove the cap.
Oh,
There is the protection here. Put it on the back and go.
Dude.
Yeah.
That's really...
We're
Okay. Here, David, I got you some water. Because I opened it with this bottle opener.
Oh.
Keep it safe for me.
Oh, is this for you to drink?
Well, it's for you, if you want to drink it. Oh. Thank you.
John,
dude.
It was a pleasure to meet you.
Super good to meet you. Thank you for these wonderful gifts.
Take care.
Oh,
Bye.
yeah. Bye-bye. We've got more from EOS coming up. Right, David?
Yes, sir.
Yeah, we do. It's not just pens and bottle openers and cool things for liquid natural gas. We got more. What does that do? Why are you hitting the button? Oh. This is cool. Look at these. Here, look at this. Zoom in right there. How cool is that? That is a metal printed pen. And then the bottle opener almost looks like a ship. Oh, we got more people. Here, I'll hide this. I'll put this down here. There we go. Okay.
Hey.
Oh my goodness. Hey, I'm Joel.
I'm Dominic.
Good to meet you.
Yeah.
Here, come on around here so we can see your wonderful face. From EOS.
From EOS.
Now, what am I holding here?
This is you cannot see the journey of this part. It's done by simulation.
Okay.
It's a high pressure valve for the oil and gas industry, and it can take up to 450 psi.
Oh.
Which is extremely high stress.
Yeah.
And it's like 31 bars, right? As in bars, it's something like, it's an equivalent of 300 meters below sea level.
I see what you're saying. Yes,
Each
yes.
meter. It's not operating in 300 meters here at sea level,
That's
but
right, yeah.
equivalent, very high pressure valve. And the challenge was, this is done usually with metal.
Right, of course, you would mill out a shape and it would have to look a certain way and you would have a big metal part.
Exactly, and it's working in a very corrosive environment.
That's right.
Oil and gas. And they have huge problems with these metal parts. So they started to find out that polymer, which is also very chemical resistant, might do also a very good job for the sealing of such valves.
Oh, okay. So what polymer is this?
Pier 12.
Oh,
Pier
wait.
2200.
This is nylon?
This is nylon, yeah.
Oh.
It's still bulky. It's not a typical polymer part because it's not complex and it's 1.7 kilo weight.
Right, but it doesn't.
It's quite heavy and bulky, right?
It doesn't feel like a nylon to me.
Ah, okay.
It feels, I don't know, it feels like a manufactured part rather than a printed part.
That's good.
Well, yeah, I know. But it's
That's
really
even
cool
better.
that like a PA12 part can withstand that level of pressure.
Exactly. They have started actually with a different design, and then this design was called a complete structural collapse. By simulation, we found out that was 120 megapascal, which is easily 4 times more than Pier 12 can withstand.
Okay.
And then we started to redesign it based on, I know it doesn't look like a typical topology optimized part, but we did topology optimization to better understand how it's supposed to look like.
Well, usually topology is for, well, I mean, I've seen a lot of simulations where you've got a point here and a point here, and you put material, and it's like, what is the shape that can support this load to this? But instead, you're like, you've got this much pressure over this much space. What shape can hold that the best, right? Knowing what PA12's characteristics are.
Exactly. And in this case, like, the pressure comes from, like, here's the ceiling, and the pressure comes from the top, and you need to imagine this is kind of a, like a church window, right? So this is the force and the weight from the chirp might flow into the ceiling, also to have a more tight.
I see.
Ceiling. And then also the first design was flat, and that indicates more stress. And then it was like a bunch of parts. And by doing this in a dome shape, you can then suddenly withstand this high pressure. It sounds very easily, but topology can change this white elephant in your head and change the design how you initially approached it to a design which maybe then.
Sometimes topology optimization can prove the thing that you're thinking. Because it could be, I mean, I'm sure that there were designs of this that removed some material, but the topology optimization showed you exactly which material to remove, right? And which spines to leave and all of that.
Yeah, and then we used the stress and the strain and some of the entities, and then finally it was successful. It's a API. This is an American Petro, how do you say, testing procedure.
Oh,
and
okay.
They do it in long with different, how do you say, hypershell, hyperstatic shell testing, hypershell seed.
Hypostatic shell testing.
Hydrostatic, sorry.
Hydrostatic shell.
Okay. What did I say? Hyper is also.
I mean, I don't even know what that is either, so it's all right.
Hypostatic. And also with water, with air, with nitrogen, there's a procedure for this. Yeah, it's. We asked them to maybe if we can change the design of this thing, but they said no. This is the way that it's manufactured conventionally, and
wow.
And this is how it fits into these channels because it needs to also open and close. Yeah.
So then, okay, I know we're kind of running short on time, but I've got one more question that I really want to ask you because the process that made this is really incredible, and so I'm wondering has that opened doors for EOS as far as problems that they can now solve? Like now that this is possible and you've done the things and you've made the thing, and it's like, wow, that works. As all of a sudden, is it like, oh wow, that means we can do this and we can do this? Has it opened more doors?
Absolutely. Because by doing simulation, this is the first time we can do simulation also for metal. This is quite usual, but for polymer, it's a new field. And this gives, I think, confidence and trust and evidence also to the designer to go into such super critical industries and application with 3D printing. And this open eyes.
There's a lot of...
for the principal engineers on their side, on the valve company, it was really eye-opening.
There's going to be a lot of really cool legacy applications that can now use 3D printed parts because this now exists. Dominic, thank you so much for showing me this really cool stuff, man. Look at that thing. Absolutely. Yeah, there you go. There you go. Well, here, I'm not going to keep that. That's yours. You can have that. Yeah.
Thank you, Joe.
Thank you very much. Whew. Oh, can I talk for a minute?
Just a quick minute.
Okay, I'm going to talk for a quick minute. Hey, everybody. Bring Vincento back. Oh, I love Vincento. These are so cool. Agreed. More titanium things. I love it. 3D printing titanium sounds awesome. I agree. Doctor Who looking pen, yes. Feels like he was rushed off. With the amount of time we have, I will, after the stream, I'll go find Vincento and we will have a conversation, I promise. Because he was cool and he gave me cool stuff. So I'll make sure that happens. Joe Cahill, where is Prusa at? I don't know. Maybe coming later, maybe? Okay. Take away the table. All right, I've rescued my water. Oh, is that coming on?
Yes.
Ooh, okay.
Can you give me a hand?
Oh, yeah. All right, there you go. Cool. Peter, I'm gonna keep my pen right there. Oh, you guys, you all are gonna love this. You need more turning radius. Oh, you're bringing it up here. Oh my gosh, okay. Next up is, well, this is just friggin' cool. Someone who you've seen before using some material you're very familiar with. Oh, you all mic'd up?
I'm mic'd up.
You might.
Do you want me over here or over there?
I don't, what? Over here, over here, yeah.
Hey,
Here,
Joe.
I'm gonna set that aside. Good to see you, Matt. Jeez. I'm gonna set that right there. There we go.
Can you actually get that in shot from up here?
I don't know. Peter, you getting it all? So Matt, you are, I would say, famous for enlarging Lego bricks and making incredible things out of them.
Lego inspired.
Lego inspired for.
Yes.
I'm sorry. For Lego inspired
Yes.
bricks. Yes.
Building
We
blocks,
don't we
yes.
don't want the chop.
No,
we don't
exactly,
need the
yes.
yeah. But this is quite possibly the largest Lego inspired large brick creation you've made.
Yes.
Correct me if I'm wrong.
No, this is correct. This is the largest scale I've ever gone to. There is one model that I've recently done that's slightly longer, smaller scale, but
Okay.
never this big in size. So this is 10.42 times larger than normal. And the 10.42 comes about from Lego axles being 4.8 millimeters in diameter.
Yeah.
And if you scale that by 10.42, roughly gives you a 50 mil size, and that's a 50 mil bearing. So it's easy to find the bearings to fit.
Yeah, I was just gonna say that makes a lot of sense.
Prior to that, it was 8.3 was the biggest I'd gone to, which is a 40 mil bearing.
Okay.
And prior to that was 5 scale, which was a 24 mil bearing. So
Okay, but a 50 mil bearing is going to be the biggest bearing you've used.
Exactly.
Okay.
So this is the biggest scale I've ever done, and by far the most. I've printed 102 kilos of filament.
That I did a 7-foot tall Galactus
Oh, yeah.
statue, and it used 96 kilos, and I was like, boy, that's a lot.
Yeah.
Oh, I guess not.
102 kilos of filament here, and probably about 15 kilos of failed prints.
Oh.
It was a horrible job. this one.
Really?
It's
Why?
hard.
Why? It's just you just hit a button and walk away, right?
Yeah, but I had one printer that was capable of doing the really long beams, which was an old belt printer, and it kept failing.
Oh,
and I only had the
okay.
one, and it would fail and lose position, and then everything would be offset, and I'd be 22 hours into a print and 3 kilos in, and it was. Yeah, it was hard work, this one. I started this in May this year, and I finished it about 4 weeks ago. So
In May?
In May.
This has been going since May?
Yep. Yep. I promised Polymaker, who gave me all this filament, that I'd come bring this to their stand for Formnext. So I was like, it's nice to have a deadline. So I thought, I'll start in May, that'll give me plenty of time. And it was only just,
Yeah.
you know.
That's how that works out.
Yep.
So this is all Polymaker material.
Yep.
Is it Polymaker Polylite?
Polysonic. A lot of it's Polysonic, to be honest.
Polysonic, okay.
Polysonic,
Yeah.
I did get a volcano nozzle onto the belt prints, right? It was great, just so I'll get a bit more throughput. TPU tires.
Yeah,
with,
and now done in sections, it looks like.
They're done in quadrants, but the inner core is in one piece, which was printed on the Prusa XL.
Okay.
So it's an inner PLA core with quadrants of TPU joined onto
okay.
it to save time of
Yeah.
TPU printing. Yeah. But pretty much, I think that actually this yellow is ASA because I couldn't find a nice yellow match, and so we've used ASA for the yellow. But,
That's great quality on the ASA prints, because I'm sure you were going as fast as you could.
Exactly.
Yeah.
So most of it, so the belt printer I fitted with a 1mm nozzle, 2 perimeters. Yeah.
Yeah, I
You
can see right
there's a-
there.
there's a
Yeah, I
filament
was like,
change.
oh, look at that.
Yeah,
Yep.
filament change.
Yep.
It was a really lovely feature of the belt printer was that when you do a pause, it doesn't. The Z position sort of changes a bit, and each time you pause, the piece gets slightly shorter.
Yep.
So I'm like, why is that happening? So one of the pieces on here somewhere, over here, had like 12 pauses in it, and it ended up being 4 mil shorter than it should have been. So, yeah.
So you just drill it out?
Drilled it out,
Yeah,
yeah, I
yeah,
couldn't
yeah,
be
of course.
bothered at that
No,
point,
don't be bothered to do that anymore.
Yeah, and the lighter pieces, if it's not structural, I'll do them on the bamboo or the Prusa, and they'll be a 0.8 nozzle, 2 perimeters.
Oh, okay.
5%
Super
increase.
strong. I mean,
Oh, yes.
a 0.8 nozzle, 2 perimeters. Like then
yeah.
it's 1.6 thick or
Exactly.
1.5 thick, and you're like,
It's good enough.
yeah, it's great.
This is all flimsy, but you know.
Yeah, but I mean, you're not doing handstands on that. No. But when you came up, you were sitting in there.
Yeah, I
like
drove it in.
driving it.
Yeah.
Like you.
Yeah.
How far did you? Because Polymaker
We came-
is over there, right?
Yeah, we're upstairs. I had to get someone to operate the big cargo lift for us, and came down in the lift, came across the full court into 11. Yeah.
Oh, you came across like.
Well, they came down the lift to the floor lift to this level, and then
Yeah.
drove all the way across the forecourt here, and then
No
through
problem?
through the doors. Nobody stopped us. Yeah, it's quite weird.
Nobody stopped you?
Yeah. Usually as soon as you
Yeah.
fire up any vehicle here and try driving anywhere, it's like no. But yeah.
Yeah, but I guess they just let Lego inspired bricks through.
Yeah, there you go. Lego
Wow.
inspired. Nicely done.
Yeah, I got that. Yeah. What was the hardest part of this whole project? Was it, well, because I'm wondering, because I did my own large scale project where I scaled up pieces, and you obviously took a 10.42x, right?
Yeah.
So in doing that, was there anything that you ran into that you hadn't experienced before?
With this one, I mean, just the sheer volume to print was hard work. And having that one, but I usually have multiple printers, which makes everything easier.
Oh yeah, I
If
know.
one breaks down, you go, oh, I'll use that one, and I'll get that one going. You get 2 pieces printed at a time. But having one printer, and you're stuck waiting for that part to finish before you can load up another one, and trying to keep the throughput of parts, that was just hard work. Because it was like going back to the old days where I had one Rollsbot printer, and I printed the 5x scale stuff. And then I got 2, and it's like, oh, that's infinitely easier.
Oh,
then I
yeah.
got 3, and it was easier. But having one again was just, it's like, oh, this is back in the old days.
Yeah, it's difficult because the fastest throughput with one printer is waking up when that one is ready to go.
Exactly,
and then,
feeding in more. And then also, I could only get the Polysonic in 1 kilo reels.
Oh, Matt, are you serious? Wait.
Yeah, so every time.
This is 101 kilo reels worth of material?
Pretty much. Yeah, so that was brutal. Figuring out how to do the ties at this scale, took a little bit of design work in the CAD, and I'm really proud of how they came out, because the inner core sort of snap fits into those 4 quadrants.
Yeah.
And I thought I was going to have to glue it, but in the end, there was a really lovely keyway and snap fit system, and then I did end up putting some self tappers in from behind.
Okay.
But to be honest, I probably didn't need them.
It's gravity's holding it too. It's not like you're, and it's not like you're doing 70 miles per hour down the highway.
No, this is really slow at the moment. That's stage 2 of this is going to be getting the drivetrain working much.
And then you'll
better
take it on drift
faster.
courses.
It's one stage at a time.
Yeah.
And the suspension as well. So the geometry of the suspension on this kit, because this is copied from an original toy, but the geometry was awful. It looks fun, and there's loads of suspension travel, but awful geometry. So I got these springs that fit off the shelf, and they weren't powerful enough to even hold its own weight up. So I got even bigger springs, because I've got to get in it as well.
Of course.
And they didn't work. So in the end, I was like, I'm going to have to change the geometry. And I came in 1 peg on the Technic axle, and that was all it wanted, just because you'll get mechanical advantage.
Really? Well, yeah, of course. But I mean,
but the original kit was just awful. And it's one of the main comments on my YouTube video for this. Is like, I'm an engineer, I'm a car engineer, and that geometry of suspension is never going to work. And they're absolutely right. It's terrible, But,
Well, that's kind of interesting because these builds really get seen by a lot of people with certain skill sets that are familiar with making cars, as an example. So, like, was there any comments where people are like, oh, I proved you wrong, or oh, I can't believe you did that, or I'm surprised, or?
To be honest, what's really lovely about doing this one and the last video I did was the 1980s car chassis kit. This is another beautiful, inspirational Lego Technic kit. And the amount of comments, the stories of this nostalgia of Christmas Day and getting this, and in my video I talk about how Lego inspired me to get into engineering originally. That's what got me going into engineering. So many other people have the same story. So many people are like, oh, I'm an engineer now and I used to play with Lego Technic. I'm a car mechanic, I used to play with Lego Technic. This is one of my first cars and blah, 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 So I think Lego has a lot to answer for a lot of inspired engineers, young engineers.
That's probably why they're letting you get away with it, right?
I hope so. Well, they should see this as my love letter to them, because this was,
of course.
my inspiration came from my childhood, and I ended up a software and electronics engineer, but obviously a mechanical side of it as well. So hopefully they appreciate it rather than see it as a.
Have they ever reached out?
I've met a couple of people from Lego at this show.
Oh.
And they are, well, I think officially they wouldn't comment. Unofficially, I think they like it.
Okay.
That's my understanding of it. So yeah.
Lego has one kit with a 3D printed piece in it now.
I've heard, yeah.
It's a train and has a little printed animal, I think it is.
Yeah, that's right, yeah.
I was at, we were in Florida recently and I got to see it.
Yeah.
And it didn't look special. No. Like it didn't, it was SLS printed or whatever, but it's just neat to see something that's been around for so long.
Yeah.
I don't know.
Because it's obviously from a mass production point of view, you wouldn't think that a 3D printed part would make sense.
But there you go.
Yeah. So yeah.
Matt, this is so cool, man. Is this is this the finale of a large Lego inspired build series?
I have actually said to Luke at Polymaker, I think this might be the last, because I don't really know where to go from here. Other than I've got a second video plan for this to make it, to motorize it. The car chassis I want to make radio controlled because it's too small to sit on. But I don't really know where to go from this point, and it feels like I can't go any bigger.
Well, what's the next size of bearings that you would use?
60 mil.
Okay.
So it's 12 point something.
I was like, you've already calculated this, right?
I looked at doing this one at 60 mil bearings.
Did you really?
But the volume increase, to go from 8.3x to 10.4x is a double in volume, twice the volume. It's only 25% size increase. The cube
but because
ratio,
you're the cube,
it's double
what
the
they call
volume.
the square cube law or whatever.
It's horrific. So I just don't know that you could go. Well, you could go again. I mean, if someone wanted to pay me to do it, maybe I'd do it. But
sure. Well, there's a lot of things I would do differently if someone was going to pay me a bunch of money for it. Sure.
But there's so much work and so much time invested, and I certainly wouldn't want to do it with that one belt printer.
No, of course not.
So yeah, I don't know whether this will be the end or not. But
is any adhesives used, or is it still interlocking?
A couple of places. Yeah, I've used some adhesive. I think on the steering sections here, these two are glued together.
Okay.
Because they were pulling apart. There's 2 bolts down through here onto the chassis. That's the only bolted section in the whole car. All of the Technic axles are printed in multiple sections, upright on actually I did that on the P1S machine.
Oh, okay.
And inside of that, on the roll cage, is aluminium square section.
Okay, so there's strength up there.
Yes, and then the chassis is steel square section.
Okay, good.
So that holds it all together.
I mean, you're not just sitting on a bunch of plastic?
No, there's some steel, and the design works really well because there's 2 big steel sections that run inside these axles right through the middle of the chassis. It pins it all together nicely. So.
Oh, that's great.
Yeah.
What's the weight limit? Like, is it rated for you, rated for me?
At the moment,
you and me?
Yeah, it's probably 85 kilos.
Okay.
Sorry.
That's all right.
Sorry.
No, I have to eat less pizza, and I like pizza too much.
I put this, in the video you'll see, at the end of the video, I noticed that the rear chassis rails are separating.
Oh.
So I've actually fixed that now, but that will be in my second video, my update video. But I don't know how far I can push that. I'm already pushing my luck with it.
Yeah, you are. This
doesn't
fit through a doorway.
Yeah,
like a conventional doorway, right?
Yeah, double door.
Has to be double door, yeah. So then something like this, your garage? I'm guessing?
It's all right in my garage, yeah. I've got a old vintage Morris Minor that sits next to it. It's quite nice. It actually makes the Morris Minor look quite big. It's just tiny next to any other more ordinary car. But yeah, it sits in the garage at the moment. Next to the car chassis.
Yeah, of course, of course.
So yeah, and then who knows what's going to happen to it.
Well, I mean, beyond this though, like you said, if this is the swan song of your large Lego-inspired build stuff, you're still you're a curious person. You're a DIYer. You like to make stuff. Like, is there anything else tickling your brain at this moment where you're like, hey, at next Formnext, maybe I'll make something that
I don't know.
a suit or something that flies or.
Well, I brought the jetpack here 2 years ago, but it wasn't flying then.
No,
but I don't know, to be honest. I suppose I've got to think of something if I want to come back. If I want to be invited back by Polymaker.
I think they'll let you come back just to hang out, but having projects at the booth is kind of cool.
Yeah, I don't know. I'll see. Maybe I'll come up with something else by then. But at the moment, I think I just want to break because I had a whole summer of doing 3D printing and assembly of various Lego-inspired kits. And I thought I was going to have a break for a bit. I will go back and I did a radio control lawnmower this year, which was sort of kind of 3D printed. I used high temperature PLA from Polymaker, which is amazing.
It is great material.
Yeah, really good.
Yeah.
So that was fun. I might go back and do an E conversion of that because it's petrol electric at the moment. So go fully electric. But as for stuff for here and future of this, I don't really know.
Any droid stuff?
Possibly.
Yeah?
Yeah, possibly. I've got a little,
you can't never get fully away from that, right?
Well, I took a little bit of sabbatical from my work. You mean Star Wars stuff? I took a little bit of break. I did do some work this year on it, but not much.
Okay.
But I have a little droid possible project to do with Prusa, actually. So
we'll see,
really? See what happens, yeah.
Well, that could be fun.
Yeah.
Maybe that's your Formnext thing next year.
It could be. Yeah, you never know. Maybe.
Instead of having this, have a little droid.
Yeah.
Are the plans for this available?
I've released the 5X version, which is based on the original kit without all of the modifications I had to make.
Oh.
Yeah, so if you wanted to make a model, just put it on your shelf.
Yeah, I was going to say 5X isn't something I'm going to be sitting on.
No. So it will print between 2.5X and 5X scale, which is obviously half this.
And you wouldn't need the reinforcements.
No.
Because it's just going to be decorative.
Exactly. Yeah. Exactly. You're using a fraction of the filament. So,
Square cube law goes both ways. Yeah.
So I've done the 5X. I don't know whether I'll release. There's so many modifications to do, and then I've got to get into where you buy the steel, where you buy the axle, where you buy the bearings, how do you assemble it, how do you do you glue this bit, do you glue that bit? There's a lot of work in the assembly manual and stuff. So, which is why I never released the files for the bike yet, because everyone wanted the monkey bike.
Oh yeah.
And I get asked for that all the time when you release the files. But then I've got to release where I got the springs from, how you assemble the spring assembly, because it has steel reinforcement inside of the prints and So I don't know. We'll see.
What's the difference between creating one and creating like 100, right?
Exactly.
Your process of creating one is like literally hodgepodge and magic and a little sawdust in places, and you're good.
That's exactly. I've worked in the film industry for 30 years, and we only ever create one.
Yeah,
we make one puppet or one creature or character, and then we film it for 2 months or a week, and then you walk away. It's lovely.
You make one thing, it looks really good from this angle, and then it goes into a backlot somewhere, and it's never seen from again.
Yeah. So mass production is not my thing. I get one. Crack the nut, walk on, and carry on and do something else.
Yeah, that's fair. Yeah, you don't want to.
Yeah.
Dude, this is. It's one of those things where it's so inspiring to look at. Like you said, you saw Lego people.
Yeah.
They inspired to be engineers. Like this has to be. You could easily take this to schools in the UK, and just like schools would have assemblies around it, or you could take it to engineering classes. And
I've had over the years since I've been 3D printing, especially since I started the little Lego go-kart years ago with my nephew, it was almost 10 years ago now. A lot of people have come up at shows like this and other shows, mostly like, I guess, fathers of children, and they said, you got me and my child into 3D printing because when he saw the giant scaled Lego kit you scaled up, and he was like, can we get a 3D printer? So started printing, scaled up Lego-inspired kits. So it's nice that fed back. And
absolutely.
It inspires kids to do stuff like that.
It could be this project that inspires some kid to become an engineer that solves a problem that saves humanity or sends us to the stars or something. You never know. You never know.
So that's a nice aspect of it, I guess. And I suppose it's that instantly recognisable thing. Nearly everyone knows it, and all ages go, oh my God, it's
Oh yeah, absolutely.
I took my monkey bike to a steam fair in the summer. It's like a big traction engine, steam engines, what have you. And I was riding around the fair on this giant scale Lego-inspired monkey bike, and you could just hear everybody I was riding by. I was like, no, look at the Lego thing, look at the Lego monkey. It's just. Everyone stops, like hardened engineers, Cornish engineers, and it's just like, oh my God,
Dude, this has been amazing. I am so happy you were able to bring this down.
Yeah, no
it's so good to see you.
Let's get it back in the lift and get it back upstairs.
Well, I mean, it shouldn't be a problem.
No.
Just go do donuts out there.
Yeah.
Well, it's only 5:40. Like, the show's almost over. Like, you've got plenty of room to run around here.
It's beer o'clock, isn't it?
No drinking and driving.
Oh, right, yes.
Yeah.
When you go back.
Oh, thank you. Dude, thanks, Matt. All right.
Cheers, mate.
That was that was awesome. It's funny how Lego has spawned projects like this and nanoblocks on the other end of the scale. It's true. I think one of the incredible things that we get from Lego is that it breeds imagination, and it lets people who can think of really cool stuff make that cool stuff in ways that one might not think is possible. I love Lego. I love it. Matt Denton on YouTube. That's right. Matt Denton on YouTube. Wait, Matt, what's your YouTube?
Matt Denton.
Is it? Ooh, okay. So if you go to YouTube and look up just Matt Denton, all one word.
Oh, it's Instagram. Mantis Robot on Instagram.
Yeah, Mantis Robot on Instagram, yeah. All right. Big Giano, what's up, man? Sounds like it's been a cool Formnext so far. It most certainly has. Wetworks work, we sing the Stone Wolf today.
Stone Wolf's at the booth of the BQ booth.
Yeah, they're at the BQ booth. We get to, they're not gonna, Stone Wolf isn't gonna be on stream, but, well, I'm gonna stop by the BQ booth and say hi, for sure, because I love that guy. Moji, I dare say that the vast majority of 3D printers were Lego kids. I know I was, for sure. Bye, Matt. You need a horn. Oh. That was good times, all right. Oh, okay, good. David got the microphone. I was like, oh shoot, did David get the microphone? I guess he did. That's good. Oh, look at everybody. There goes Matt. I love it. That's amazing. We just see it on the screen. I'm looking at it on the playback there. That is amazing. Just drives away. Are you ordering your index there at the show? Not yet. I'm planning on it. I am planning on it. Joel, don't forget a shameless CMI plug. Make manufacturing popular again. The CMI is cool. Yes, it is cool. Oh, yeah, I'm ready. I'm ready. All right. David, here's your iPad.
Hi, Joel. Nice to meet you.
Hello, hello. I'm Joel.
I'm Matt.
Hey, Matt. Good to meet you. Let me put. Matts are cool.
Yeah, I'm good. Thank you.
Well, Matt, you're from Stratasys.
I am from Stratasys.
This
yes.
looks like a drone.
It is indeed. Yeah, the TV.
Which means it's probably been 3D printed, right?
It has. It has.
Take me through it.
So there's two technologies. We've got FDM and also PolyJet on this one.
Okay.
So it started off as prototyping, concept modeling, that sort of idea.
Yeah.
And then to camouflage it with PolyJet, obviously in colors and texture. But this is actually from a company called Skytech. It's a modular system.
Oh my God, it just felt, okay,
it
yeah.
fell off on purpose, I promise.
Yeah.
So it clicks together, and then you have a release mechanism underneath, and you can swap it
for
different arm lengths and obviously rotor sizes as well. So for longer endurance, different things like that for reconnaissance and things.
So you've got the same brain on there, the camera system, everything, and you're just like
completely modular.
You're just like switching nozzles on a consumer 3D printer. You're just
change the camera out, change the battery, payload, whatever you want from there. On there as well, and it all gets back put back together.
That's cool, because these used in the field, obviously, you might need more lifting strength, or you might need more distance, or you might need more flight time, or whatever. So you can customize the actual FPV itself to support the things that you need in the field without having to bring a bunch of different FPVs.
Exactly. If you want to do 2.5 kilos, 5 kilos, 10 kilos, different payloads, does it for you perfectly.
Now, in the 3D printing section, though, what was the reason to go 3D printing for this?
I think it's scalability and quantities that they want to do. So whether you want 1 or 2 off at a point of need, or you want to scale to thousands of, then it makes sense. Depending whether it's SDM or if you go into DLP or a powder-based technology, they're all like economy of scale.
I see. So someone could say, I need 3 of these with these arm lengths and these props on it, and you could just then you set them to go, and they're ready.
Yep.
Oh, so so 3D printing then, like you said, is for scale, so you don't have to maintain a warehouse of thousands of everything. No. You make the things you need at the time.
I think so, like, for especially in this environment, for the defense side of things, it's from factory to foxhole. So, you know, at the factory, they're going to be building hundreds, thousands of them, but in the field, it's what they want when they want at the point of need.
Yeah.
Unfortunately.
Dang, okay. That's pretty cool. And obviously you're using standard FPV motors.
Yep. Nothing different. Props can be done in PP. They can be done in different materials as well, or carbon fiber, depending on, again, deflection loads and things like that.
What have you found in 3D printing props? Like, is PP really that good for props over like an injection molded?
Hit and miss.
Is it?
I'll be honest with you.
Okay.
Yeah. But if you need something doing quick and you don't have anything else available, then it'll do the job pretty well.
Oh, okay. I see what you're saying. Oh, that's cool.
But this is like the smaller example. Then it's.
Can I hold this?
Yeah, feel free. Then it's higher altitude, long endurance, short endurance, medium altitude. So things like the much larger wingspans as well for carrying cargo, carrying other drones in, land-based systems, anything to do with autonomy. It's not just flying. So it could be surface going, subsea stuff as well.
I see.
There's a massive obsession with FPVs, I think, and 3D printing. There's a lot more that can be done.
Well, a lot of people think 3D printing for customization of this sort of thing.
Yep.
But when we talk about deployment and having to use things like this in certain areas where you can't bring a warehouse of parts with you, but you can bring a machine that can make the parts, especially if you're just like, I need this right away as fast as you can.
What you want, yeah.
What do you do? You have to print the part.
Yep.
And then, like you said, autonomous things, right?
Yeah, it's absolutely anything and everything, as the viewers will probably know. But this, as a prototype, so it's from ASA and a bit of polyjet. Then you're going off to nylons with carbon fiber on the inside, 35% weight. Depends on what you want.
As a prototype, has this flown?
Yes.
Does it fly well?
It does. So the company's called Skytech, and they've got videos online. You can see it whipping around the desert and things as well.
Did you fly it?
I did not.
Okay.
I don't have the relevant
Did you
skill set.
not or did you not?
I did not.
Okay.
So yeah, it's a good little example, so we thought we'd bring it down.
So then did you, Stratasys, make this for them, or did they have Stratasys machines?
No, they have our machines. They did all the R&D development and then went into sort of serial production with it. So
okay, so you as a company then provide, who they purchased the machines from, you're like, hey, that's a cool use case.
Exactly.
Can we show it?
Yeah.
And they're like, boy, howdy.
They're quite happy to,
Yeah, absolutely.
Drop the name.
Of course. Oh, I bet this has been popular at your booth at Formnext.
It has. There's different iterations up there on the stand as well, which is pretty good. But it's not just polyjet, so there's like silicone parts on there from the Origin machine, all sorts of different bits as well.
What would you say the percentage is of 3D printing as far as this kit goes?
80%?
80%?
That's 85%
Yeah?
of it is.
That's considerable.
Yeah, it's a massive amount. I was not going to get that out quite yet, but you can do. Go for
Can
it.
you take this out? Because we only have a little bit of time to make sure we get this.
So this is silicone.
Yeah, it is silicone.
It is. So this is printed on the Origin machine. You can give it a really good tug, give it a pull.
Okay.
So it's over 600% elongation of break.
Really?
Yeah, it's crazy. It's also, you can whack people on the head with it.
Oh.
It has other uses like gaskets and things as well.
Yeah, I mean, gaskets and seals
and stuff, yeah.
Sure, but I mean...
You can keep tugging on it all day, it's good.
This is just stupid fun, right? I mean,
fun.
Everybody's been hitting stuff with this thing, right?
No comment.
So then, is this just a showpiece, or is there an actual functional use for this?
That's a total showpiece.
Okay,
Yeah,
I was like, I don't know.
showpiece.
This looks like a piece of licorice that's been enlarged.
It is, yeah. So it's gaskets, it's seals, it's ducting, it's grommets,
Yeah?
that sort of stuff as well. You're gonna hit it?
We're gonna hit something. How are we gonna hit the bench?
Move it back.
You want me to just smack it? Smack it a little bit? Here, give it a go.
Me?
Yeah.
That's good. It's not something I'm normally allowed to do at work.
I know. Here, go. We'll go. No, come on. Yeah, come on. Here, let's see these others. But gasketing, one of those things. Like to make a traditional silicone gasket, how would you go about doing that?
You'd mold it, I guess. Would be the typical way.
Yeah, right.
Yeah. So this is totally new. What's nice about this is it's a true silicone as well. Has the same massive elongation of break, but it's also HDT is nearly 200 degrees C.
Really?
Yeah, it has UL94 compliance as well, V0 at 3mm wall thickness. So it actually has a lot more applications than standard rubbers, elastomerics, as well as.
And then.
That's pretty cool.
Here, let's move this. Aaron, you go ahead and take that down. Yeah, that was fun. That's really cool, though, being able to, and this is on the Origin machine,
On the
you
Origin,
said.
yeah.
Now, the Origin machine, very, very industrial.
Yes.
Like, it's one of those machines where it just lights out 24/7 style printing.
Can be used for prototyping as well, but yeah, it's more there for manufacturing.
We were here a couple years ago, I think it was, and we saw the Origin machines with the automation, like the little farm that was there.
Yep.
And was that ever a production thing, or was that just like a showcase of what's possible?
It was a showcase of what's possible. There are a couple of customers that did something similar,
Yeah?
but not on a massive scale.
Okay.
Yeah. So maybe if they've got 4 or 5 machines, they need some robotic arms to take it off, and then it goes down a automated.
Oh,
post-processing,
yeah, okay,
that
okay.
sort of thing. But
That's
that's
kinda
been done with FDM as well.
Yeah, of course. Isn't it crazy the technology we have nowadays with the processes that have been around forever? Like, did you ever think FDM would be able to do what it's able to do?
No, so I've been in AM for 18, 19 years. So a long
okay,
time. I used to work on some old kit, and before I joined Stratasys, I was at a company called Envision Tech.
Okay.
I was there for 11 years, and things have just massively shot forward, and Stratasys and the way that our portfolio has gone is crazy. But the software, post-processing kit, it's all part of it. But it's scary. Every day is a learning day for me.
Well, seeing the resin side of things, I think it's just crazy what you can do with those materials now. Because this is not FDM, right?
No, this is DLP.
Yeah. Okay. Yeah. So
it's all DLP this year.
Yeah, but being able to do that in a DLP system, getting V0 at 3 mil wall thing, like that kind of material, like, is crazy.
It is. So I guess like photopolymers, the chemistry behind it has come on such huge leaps and bounds.
Yeah.
But it used to be you'd build something in, as soon as you pulled it, you shouldn't, with smacking a chair, you couldn't do it. But this, you could, a few years ago, you pulled it, it would tear.
It would tear easily, yeah.
Easily.
The bonds weren't there.
Even our old Tango elastic materials on Polyjet didn't have the best tear strength.
That's just one of those things, man. It's crazy too. And what's really cool is a lot of the materials, especially, stuff within the Stratasys portfolio, like those Origin machines, they've been around for years, but they're tackling these new materials that you guys are throwing at them.
Yeah.
Which I would imagine, I know the Origin machines are very specific customers that have those, but the customers that have those must be super happy being able to tackle these new solutions with these new materials. I can't stop playing with this, I'm sorry.
I think it's down to the wavelength of light as well from the projector, and then the separation process, but it's the repeatability. So it has an oven as well, so we're temperature controlling it. So things like this with the viscosity, you've got to control the viscosity to get repeatability.
Yeah, exactly, because how else are you going to,
Exactly.
yeah. Oh man, this is fun. So you said you've been in it for like 18 years.
Yeah, a long time, yeah.
So what do you have at home?
I actually have a Maker Pot machine. I have a brand that I won't mention. And I have a Stratasys machine as well.
You have a Stratasys machine at home?
Yeah.
Which one?
An old 370, F370.
Was it just decommissioned? You're like, I'll take it from you?
It came, in a roundabout way for me to play with different projects and things, but it's pretty good.
What have you made on it?
Mostly Harry Potter ones for my son. Widgets for an old boat, a kayak. What else have I done? Some spare parts for a little drone that my son has.
Okay.
Yep. Those sorts of things.
So the 370, what was the retail price of that machine when new? Do you know?
I have no idea.
It was a lot of money.
Probably.
Yeah. And isn't it just funny that you're using this incredibly industrial machine just because you have it in your house to make Harry Potter wands?
Yeah. It's fun though.
It's fun though.
And it's repeatable. That's a good thing.
Yeah, absolutely.
Same one, time and time again. I'm happy.
The first one sure looks like the 10th one.
Exactly.
Looks like the 50th one, right?
Exactly.
50th? 60th? I don't know. How many have you made?
200 he's got now.
Oh, really?
No, I don't know.
Oh my gosh.
He's got a
Regular
lot.
Harry Potter business.
He is.
What was the wand shop in Harry Potter?
Ollivanders.
Yes, that's right.
Yep.
Has he got his own little Ollivanders?
He has a massive collection of wands.
So
Anything to
cool.
do with Harry Potter. In fact, sadly enough, he has every single Lego piece.
Really?
Of Harry Potter sets, the whole thing.
If he was
They're all
missing one,
his,
you
they're
could
not
probably
mine.
make one.
They're not mine.
No, of course not.
We
I've
could.
seen that movie. Yeah. What are you guys working on now that you can mention that is cool? Or is there anything that you've had your fingers in that you can't mention yet, but you're just excited about?
There's some pretty good stuff coming. So, like for me, I'd say materials is key.
Yeah.
So, as an application engineer, I think materials drive what's possible with applications. The machine comes second. Whether it's us,
I would
or
agree
it's-
with you
or
there.
it's
Yeah,
somebody else's,
absolutely.
It doesn't matter. So, material development is the key. Whether it's glass filled, carbon fiber filled, Kevlar filled, whatever, they will push the bounds of what's in reality that customers can do, and then we have to make sure those would work on our systems or create a new system machine that would do that. That's what I get excited about. So
well, more often than not, it's working on the systems, right?
Yeah.
Like you're just having to create a new process or profile for it. Yeah. Can you mention? Is there anything cool coming?
I can't
No?
mention a
All right.
thing.
I had to try, you know.
The media boss is over there, and they'd probably sack me tomorrow if I
That's fair.
let things spill.
That's fair. How did you get into AM stuff? You said you've been doing it 18 years. You look like a spry young kid.
I'm a 43-year-old. Yeah, thank you very much. So bizarrely, I'd never heard of it at all. I was doing my apprenticeship, and a chap I was working with worked for a company called Vitron. It's a German company that did sort of automation for packaging places. And he said, he left and went and got a job at EnvisionTech and said, you need to come and look at this stuff. It was right up my street, and I joined, and that was it. And I've been in AM ever since.
They were almost slightly accidental.
I fell into it completely.
Wow. I was just going to say, what should people study to get into AM? And I guess they should study luck.
Yes. Yeah. Mechanical, electrical engineering helps.
Yeah, of course, yeah. But a little bit of luck doesn't happen.
Yeah, it does.
But it sounds like you were presented an opportunity and you went for it.
Yes, very much so.
That's one of those things, right?
Spent 11 years traveling, installing machines, working with customers, first-hand experience on the pros and the cons from it, and then came to Stratasys as an application engineer, so even more deeper diving into what we can and can't do, and to make things work,
Oh. I was just going to say, so what schooling? Did you do any schooling?
Yeah, I went to college and university as well.
Okay, so you had a traditional growing up.
Yeah, exactly. Yeah, I was lucky that I hadn't really heard of it because it wasn't in education massively at the time. If it was hidden away somewhere in the back of a department. Now it's much more readily available for people. It's in most schools in the UK. You know, my son and daughter are both learning how to do CAD already at 10 and 14. So
really?
Yeah.
So, the Harry Potter ones, did he make?
No, he designed it, Fusion.
Really?
Yeah, he did that.
Jeez, at 10?
He's 14
He's
now,
14,
so,
okay.
About 12, 13 he started doing that,
All right, well, if someone wanted to come to Stratasys and work at a type of job that you have, what do you think they should study, or what area of interest do you think they should concentrate on? Or
it's a tough question because it's mechanical engineering, electrical engineering. It could be chemistry as well. I think that Stratasys as long as you have a base education, I think in any profession somebody will be able to teach you how to do that. Nobody's going to be able to go to any other company and say, I know how the machine works, the processes, the software. It comes with time, I guess.
Okay.
So it took me at least. When I joined Stratasys, it took me 18 months to understand all the new materials, the different processes for what I was used to.
Yeah.
Just exposure.
Okay.
Get your hands dirty, play with it as much as you can.
Yeah.
Make mistakes.
Okay.
Push the boundaries, break the machines.
All right.
And then,
I like that.
Figure out how to fix them.
All right. Well, Matt, this has been fun, man.
Cheers, thank you.
Thank you for coming on here. Thank you for showing me this fun stuff. I mean, I have an old Stratasys banana.
Yeah.
And
the Polyjet job.
Yes, and I pounded it. I just showing people pound. One day it went.
Yeah.
But inside looks like a banana.
It's green as white. Yes,
yeah. It's inside. Yeah. It's got a. It's crazy.
Just a shell of color. Cheers. Thank you.
Thank you, Matt. This has been rad. David, will you recover the mic? All right. Oh my goodness. I know who's coming up. I know what's happening now. Oh, I'm coming. Oh, all right. Oh, next up is Prusa. That's right. Hi there.
You're my favorite 3D printing YouTuber.
Oh, really?
Yeah.
Here, come on. So we're filming. We're on stream right now, so we got to be quick. But I'm your favorite.
Yes.
Thank you very much.
Can you please sign this paper?
Aww. Aww. Pick it up real quick. Pick it up real quick. Come on. Come on. Pick it up. It's all right. There we go. Okay. What's your name?
Benny.
Benny. I'm Joel. It's really good to meet you. And you want me to do what now?
To sign this paper.
Sure. Just right across here?
Okay. Yes.
Okay, I can do that. I go like this. I go 3D, PN, and I go Joel, and I go just like that.
Thank you.
Oh, can I get a high five? Sweet. Have a good rest of Formnext.
What?
Have a good rest of the show, Formnext. Yeah, have a good time with it.
Thank you.
Yeah, you're welcome. See you later.
See you. Bye.
Bye-bye. Well, that was awesome. Okay, you can bring it back up now.
Oh, do you want to use the smaller table?
Where do you want to have it?
Do you want to have it on this?
I don't know.
I'm sorry. You have.
Hey,
hello.
I guess. Yeah.
Hello, everyone. I guess.
Do you want to slide this?
You want to plug it in?
Are we live?
Yeah.
You have a very small table.
It's not what I was told.
Is this table for ants?
All right, here, can you come toward me with this table? Say when, Peter? When? Okay.
There we go. We've got power. Dude.
Where?
All right, you're over here.
You will be like this.
Yo, hey, he's even mic'd up.
I am.
You are the last guest here on the live show for 2025. We saved the last spot just for you. Oh, here, come out this way so we can see you.
Oh, you moving them?
There we go. Which way? Oh, towards me.
Oh, be careful.
Ooh,
We don't want.
okay, no,
we
I
don't
don't
want you to get
Right
hurt.
here? Okay. You stay there.
I will try.
Are we good? Peter's working on it. He's good.
I hope so.
Okay, we're good.
See,
Okay.
See. Yeah.
Oh, wait a minute. Here, I got it. Cheers, man.
Cheers.
Yeah, good to have you on the show.
How are you holding up?
I'm doing okay. It was a long flight, but it's
yeah.
worth it. It's worth it to come here.
I mean, you get a little bit of what I get a couple of times a year when I fly to meet you guys in the States.
Yeah, you should come back sometime.
I do quite often actually now.
Really?
Once we have the factory.
Oh, right.
It's Wilmington, Delaware.
It's Delaware,
And
yeah.
But it's not pleasure because I usually do like one night.
That's it?
Yes. Washington in one night and out.
That's fair. Well, if you come to Seattle, you can stay a few more nights.
Okay.
So listen, this is brand new. I'm very familiar with the Core 1, the Prusa Core 1.
Mm-hmm.
Great quality, good machine. I enjoy using it. This is the Prusa Core 1L.
I am very happy because we've been fighting one thing, and that is that on the pictures, it looks quite similar. If you don't have the reference, it looks like just regular Core 1.
Yeah.
But your perfect table helped us show how big it is.
It is. Well, it's 10% larger. Is that right?
The footprint is 10% larger.
Yep.
And we've been trying to find a Goldilocks. So this was the largest we could make. So you can package it safely and can go through standard doors.
Ah, okay.
For
Yeah,
example.
that's what. Yep.
And it can fit in most of the tables. You don't have to have special equipments.
Okay.
You know the Goldilocks.
The Goldilocks size. Yeah. Well, it's usually like there's a 2 foot sort of table size that you can fit on, and yeah.
And I'm very happy about it. And actually it weighs the same as the standard Core 1.
Really?
Yes. We had to change some panels to aluminum. But yes.
Wow. What's your favorite upgrade from the Core 1 that the L has?
I love the bed.
The all overheated bed?
Yes.
Yeah.
And I always, our industry is at the stage that the manufacturing capabilities around, if we want to manufacture locally, we cannot think, we need to be very efficient. And simplicity is the key. And I always love when we can have W's for the same thing. And we have one giant powerful heater. We use it to heat the bed. And we managed to make it also the chamber heater.
Yeah.
And, basically with just 2 fans. And I really love the guys. The guys did a lot of simulation. there is a special pattern to circulate the air, and bends in the metal.
Mm-hmm.
And when it's being heated up, it's at a specific position. So the air goes and hops over.
The bed moves to a certain spot.
Over the sides, and it's doing like this. And it was another, tens of percent of faster heat up.
Yeah, but I mean, that's what simulations provide and give you that edge. One of the things I like about this machine that I've seen is the evenness in the bed heat. I did a recent printer review where I had a 30 degrees Celsius difference in bed temperature from left to right because they weren't heating the bed evenly. And I was like, that's almost unforgivable in our industry because that's the basis from which everything is built. And you have to have an even and consistent heat on the bed in order to make everything work correctly.
Yeah. And it is.
And this has that.
It's difficult. It's one of those like weird little things that you cannot find explanation to. But I mean, if it would have thermal imaging eyes, it would be obvious.
Yeah.
But figuring out why this corner lifted, even though I prepped the bed perfectly. But with the PCB beds, there's for them to work well. That's on our Core ones and other machines. You need to have the top side heated. You cannot do that with the mains voltage, but then the heat does the FR4 the substrate is insulator. It's insulating from the bottom, and you heat directly the sheet. So that's very efficient. But when manufacturing this efficient heaters with this size, to have the tolerance of the flatness is almost impossible. So we went all in, and I don't know if you noticed, but the magnets we have there, they are really chunky.
Oh, so this arrived a day or two before I had to come to Formnext, so I haven't had a chance to take this one out of the box yet. So this is actually the first time I've seen the L in person, and it looks. Oh, you need to come closer to me. I'm sorry.
I think I would like to tear the camera down if I would try to like show it. I'll do my best without damaging anything. Let me open it.
Oh wow, that was on there pretty good.
So. We have special additional magnets in the corners, and they are like we eliminated another possible weakness with glue, so they are just screwed in. Like,
okay.
They don't make them like this anymore.
No. So this is different. This is an upgrade and a difference from the Core 1 itself, right?
Yes. I mean, it's with the Core 1, we also trying to hit a certain price point. With this, we can spend a little bit more on the bill of materials.
Yeah, of course.
But it is not an upgrade. It is a sibling of the Core 1.
It's just the next iteration of the path.
Yes.
I see.
And we will be.
Come back. You got.
Okay.
There you go.
We will be taking the best quality of life changes and putting them to Core 1.
Oh really? Oh
Yes.
good. Does that include the switch for the TPU flexibles and not?
Mainly the top grill, the automatic top grill, and the TPU switch. We are not changing the bed because that would mean a lot of e-waste, and for that size, the PCB bed is the perfect. But yeah.
Because you went a little larger here on the bed, so you do need.
Yes.
There's some technical differences that you need to make. This is different on the side. Is this standard with the machine?
So this is. I'm not sure if you can see it. This is our universal storage system dry box. We will have more info tomorrow about. But we've teased it before, but it is really engineered that you can have all your materials stored for a long time. We've minimized the air volume inside, so you can like keep the material there. You need to use less silica. It lasts longer, and we even have like a special system to hold the filament, so you don't have to open it and fish out the end. You will love this.
I'm kind of excited to hear more about this. This is tomorrow, you said.
It's at our booth, but I'm not sure. I'm not sure if I like.
Well, don't take it all. I mean, don't break it.
We are too tired. I will show you tomorrow.
Yeah, tomorrow sounds
tomorrow
great.
at the booth.
Yeah, of course.
And
I would love to see it. And is there more information about your open RFD or open RFID tags?
Open print tags.
Open. There we go.
Yes,
Open print tags.
yes,
Thank
yes,
you.
yes. And
is there more information? Is this going to integrate possibly? Or?
It's compatible. I mean, the open print tags are in the spools, but I'm not sure if we are doing this like very soon. But you, as a nerd, will love this. We found a couple of weeks ago. We found a special humidity sensor, which can be powered and communicates through NFC.
Really?
So we are thinking about actually adding this as a sticker inside the USS dry box, and once the printers will be able to read through NFC the humidity inside.
Oh,
but that is
really?
Yes, but that's
future. That's. We didn't actually talk about that.
When my guys told me about this, I was nerding about it.
Yeah, I bet.
This is so cool. Anyways, but this is here now. All the machines with the new spool holders are compatible with this system.
Ooh, okay.
And yeah, I love it.
As far as the top grill, this automatically opens and shuts it depending on whatever G-code instructions are sent.
Yes.
Is that a modification people can make to the Core 1 in order to do that?
And I have something for the community. We actually had this prototype before we released the Core 1, but we didn't have it reliable enough.
Oh, okay.
But some community members, I cannot remember, came up with this. And as we did not show it, I think they deserve credit, and I'm not sure. It was not in the Core 1 article, so I want to give a shout out to the community designs who are doing the automatic grill venting. So.
Oh, that was from the community.
Yeah, we've had it on the inside, but
Yeah.
we did not show it, and community came up with it, and I think that deserves a shout out, and we did not have it in the article, so I want to get this out.
There was a time on X that you tweeted this incredible picture of these nozzles, just one right after the other, on the Core 1, and I haven't been to your booth yet. Has that picture been indicative of anything that's been shown?
I think usually for the good things, you have to wait.
Okay.
But I have a feeling the wait will not be as long, just not today.
Okay.
But maybe tomorrow.
Maybe tomorrow. Is tomorrow Friday?
It can be Friday. Yeah. But I'm incredibly excited about that.
Really?
Yes.
Okay.
But we have so much more stuff. I have stuff I can show you right now.
Right now? Oh yeah. What else do you have?
We've tried to get all the stuff people suggested that they would enjoy on our machine. So we have the new high temp nozzles.
Oh, the 400C, right?
Yes, this is a special one. It's working with the new E3D 500 Obsidian with our heater block. So this one is now in final testing. It will be available soon for every Core 1 machine, and you can, for example, you can print a full drone out of PECK KCF on the Core 1L with this.
Wait. PECK. P-E-K-K, PECK.
But CF.
PECK CF.
Yeah.
You could print that, because that's under 400. Oh, with the CF, you get under 400C on that?
Yes, a little cheat code, but people, for that use case, the CF is actually perfect.
Does PECK require the chamber to be a little hot?
I have application specialist at the booth, and I've been really tired, and I don't want to say something.
That's fair. But 400C on the Core 1 and Core 1L is possible now.
I mean, and this is abrasive resistant. There's also a high flow version of the nozzle, but this is more reliable for us now, so we are going with this.
That's really cool.
And yeah, we love it. And what were the other things? The camera is now included with the
good. Okay.
With the Core 1L, but
awesome.
because we have a large, we had to make a version for our large customer base without the camera. For the critical infrastructure.
Yep.
We've been doing, and that also does not include any radios. So this one is the first one, which is not on the secret menu, but you can buy it on the shop. We've been doing that on the XL for quite some time, but this has all the critical infrastructure edition has all the radios removed and the circuitry to support it, so you cannot plug it back covertly. And we are now certifying, validating certain. It's been a long day. Fully encrypted flash drives.
I saw that. Yes. Yeah, to be able to put it in. That's really cool. So then, for the that is a custom PCB you guys are making. Is that right?
Yes. But good thing that we, the PCB assembly is just 100 meters from my office.
Yeah, yeah. Have you ever made it have you ever prototyped something and just made a custom one?
Too much. Once when the dev department has this, when you have a tool, I think what's the saying? I'm not good at English idioms, but if you make hammers,
every tool is a hammer, right? Yeah.
Every solution is a hammer or something.
That's right. Yep.
So I mean, we solve too much things with the equipment we have. I think the record is like 20 iterations on one board.
Joe.
Well,
but it's better than sending it off to someone to make and come back to you and prototype and figure it out. And it's better than sending it back and forth 23 times.
We have to integrate. We have to integrate a lot of things to be able to iterate quickly and keep up. Because we are usually 3D printing is moving very rapidly.
It is.
And some of the industries are not used to this level of iteration. So,
no. Well, and also, speaking of rapidly though, you've introduced a liquid filament in silicone printing on the XL. So this is your first official multi-tool application. I know it's still a printing tool, but it's using a completely new filament.
Yes, I think from all the launches we have this fall, winter, it's the sleeper. A lot of when you are at the booth, you see people like, oh, this is amazing. But it's not just about silicone. Imagine all the materials which were not printable before. You could not make them into photopolymers, or you could not make them into filaments. But you can make
two-part things that can come together.
But even cements, like single parts.
Oh!
Anything.
That's kind of cool.
And I'm super excited. And actually, it's very efficient, even though we discard the tubes. So I will try to explain it without the props. Without the props.
Okay.
You have a tube.
Yep.
Filled with the liquid, and then you have stainless steel tube. You put the plastic tube over it, and you have a cutter here. And as you slip the tube across the stainless steel horn, you are pushing the material into the tube and into the mixing nozzle.
Yeah.
And we just use standard driving gears, which pull off the tube, and you could not. There's no better way to so precisely control the liquid. We have almost the same resolution as we have with regular filaments.
Okay.
It is very, very, very good. If you have a time, to come to our booth. I will show you.
Oh, I'm coming there tomorrow.
And
100%.
It will be much easier to explain everything when it's there in person. But we don't have just that for the Excel. We brought our project. We have a pick and place hat. We done in a cooperation with University from Switzerland.
Really?
It's on the booth, like putting magnets and nuts and bolts inside the 3D prints during printing.
Oh, we get to see that too.
Yes.
All right.
And we also have we have so much stuff.
I'm excited to come to the booth tomorrow.
And we also have like this. You've seen the video from John.
Oh yeah, he came by.
Yeah.
He jumped on stage and he told us it was going to be printing tomorrow.
It's up there.
All right.
So I think there's no. I think maybe. I mean, let me know, everyone.
Well, we'll come by and we'll film it. We'll show them all the cool
stuff. But I think there's no other tool changer which is as capable with printing super soft flex filaments than that machine, which is up there.
I would agree.
Should we like do it official?
Oh, maybe. I don't know. Well, I'll tell you what. We'll come visit tomorrow.
Yes.
We'll make a video, and we'll leave it to the audience to say. Dude, we're running out of time, man. I gotta shake your hand.
I talk too much. I understand.
That's all right. No, it's good talks.
I have like 5 more things, but tomorrow.
Tomorrow. Yeah. Save it for the video, Joe.
Thank you, everyone.
Dude, thanks for coming by, man.
Love you.
Right. I love you right back. It's been a while. All right. Well, this is
okay.
Well,
okay, I understand. I need to go.
No, it's just like, I got it. Oh, you got it. Okay, good. Okay. Wait, do you want to help me sign off? This is the end of the stream.
I'm not sure if I'm skilled enough for that.
We can try.
Okay.
Yeah, come here. So Joe and I are going to thank you for coming by this incredible 3D Printing Nerd stream live from Formnext 2025. There were incredible guests showing amazing things. And now the rest of the show is going to be us visiting these booths and seeing these things and committing them to film, digital card. And socials. And we've got a quiz show tomorrow. And we've got, it's going to be a wonderful time. This is a great first day. I'm going to give you one more of those. Thanks, Joe.
I love it.
Yeah.
There's no better host than you for this. And I think it is time for some refreshments.
Refreshments, you said the magic word. All right, well, thanks for making it this far. If you did, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, print all the things, and as always, high five.
Happy printing.
Oh, you want one? There it is. Yeah!
Thank you.
That was it. At the top of the YouTube one, just hit end, end it, and then confirm it. And then we are good. Sure.
Okay.
Excellent. Thank you, guys. And it will archive.